you can create an environment that's almost like the build environment the build was performed in, but not exactly like the environment that the build was performed in. So by design, Geeks has a very thoroughly, heavily isolated container that it's building the packages in. And by design, there's no way to inject into that and mess with things because that could break things. But it makes it hard to do build testing because if you have a build and it's like, well, it fails at hour 19, I know most of these steps are fine. You can't just do a partial build. So you have to rebuild the whole thing. Whereas in Debian, there are ways to kind of do a partial build test that are a little closer to what actually, so not being able to do partial builds can be really challenging for debugging purposes, at least with long-running projects. With quick projects, it's fine. You just, okay, I'll just rebuild it. But you have to iterate over, edit the Geek source, tell it to build the package again, and so there's no way to kind of cheat with Geeks, which is part of its strength and sometimes its weakness. So another whole class of issues, so I've mostly focused on reproducible builds, and that's mostly where my strength is, but also we work closely with a lot of the folks in the Bootstrappable Builds project. They're kind of sort of trying to solve, like in combination with reproducible builds, we've kind of nudged towards solving the trusting trust problem, or mostly solving. No security is ever really solving anything. It's just mostly making it better. And so a simple Debian chroot is like half a gig. That's a lot of binaries to audit. I mean, that's a crazy amount of binaries to audit. And that's just today's chroot. We have lost the historical chain of packages that came to build the current Debian. Somewhere in 1993, somebody used a compiler somewhere to build what initially became Debian, and then Debian was used to build Debian, which was used to build the next iterative versions of Debian, which was used to build the next. And we don't know. We couldn't go back and do that over again. So we could just rebuild all of Debian from scratch, maybe, and maybe once we should just try that. Yeah, so that's pretty exciting. So that makes it kind of hard to audit some very fundamental things in Debian. Now, Debian's been out there a long time, and it seems to mostly be working, and there's probably not trust vulnerabilities injected from 1993 that are still there, but there could be. It'd be nice to not have to do that. Now, Geeks, on the other hand, has a really exciting story. They've gotten it down to the point where they're booting from a 357-byte hex binary. Granted, they're using 25 megabytes of a Guile source to kind of orchestrate that process, but in theory, you could run it manually. And 357 bytes is actually pretty auditable. And I just got news from the folks working on that core project that Geeks is using. They got it down to 180 bytes. So 180 bytes of binary hex is not like, not for everybody, but it's conceivable. You can audit it. It's also well-commented code to audit. So that's the Hex 0 project. And Geeks leverages that to bootstrap itself. Granted, Geeks used to have a much bigger set of bootstrap binaries. They got it down to 357 bytes plus the little white lie of 25 megabytes. But it used to be closer to like 250 some bytes, or megabytes, if I remember correctly. But at least they recorded from the very get-go the exact things they used to bootstrap Geeks. There is a history, a chain of like, well, at this point in time, we use these binaries to bootstrap it. At this point, we use these. And because Geeks rebuilds everything, anytime you change anything at the core of Geeks, we have a pretty confident that Geeks has a pretty amazing story for bootstrapping. There are a few white lies, like some compilers are just hopeless with bootstrapping, but typically it'll go through, like Rust, there's like some version of a C compiler that can bootstrap the like Rust. I don't remember what the current version is. What's that?
It was OCaml originally that they started bootstrapping from.
Oh, okay. Well, there's a project called mrustc. I don't know if it's in C or C++. That would be confusing if it was in C++, but I think it might be. But it's actually used to bootstrap Rust 119 or so, if I remember correctly. They've been working on getting a newer version, but then geeks will go through and bootstrap, okay, Rust, you build 120 with version 119 of Rust, and then you build version 121 with version 120 of Rust. And I don't know what Rust is up to today, 140 something, 150 something, something like that. Or maybe 180 for all I know. 184, okay, yeah, see. Rust keeps moving. So that's a lot of things to bootstrap, and compilers are not exactly quick to build. So there are some weird stories like that, but they do that with Java too. I think Haskell has a cheat in there where they use some old bootstrap compiler somewhere, and but in general, the vast majority of geeks is bootstrappable from, you could trace it back to these like 357 bytes, and we're working on making that smaller so you can audit it. So in that sense, geeks has an amazing auditability story. I already made a plea for any Python developers to help us fix repro test. It'd be nice to get that back. There are a number of ways you can help. If you maintain a project, run reproducibility tests on it. Do it as a one-off, set up a CI infrastructure for it. We would love to help you if you need like a few suggestions or you're having trouble with something. We love helping people. We love seeing reproducible builds get out there more. If you want to work on the bootstrap stuff, I don't have a link up there, but I think it's bootstrappable with 2ps.org. That's a pretty awesome project. And yeah, if you love coding and really low level stuff, that's a great place to get involved. Although in bootstrapping, you can get involved at kind of any layer in the chain, because you bootstrap that hex compiler to then bootstrap a more sophisticated hex compiler that you yada 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 C compiler, complex C compiler, oh GCC ancient version, and now we can build up to current versions of stuff, more or less. So the bootstrapping sort, and you can work at any point in that chain. I think the free desktop folks have a really cool project called Live Bootstrap that actually does this all even more cleanly than Geeks does it, although Geeks does a pretty good job. And less familiar with it. I'm more involved with Debian and Geeks, but yeah. So I'm just curious. We still probably have a fair amount of time left. Thoughts, questions, dreams? How do we do this? Do we have a mic, or do I just repeat the question?
For a new developer starting out who's interested in reproducible builds for their project, what is your 30-second pitch to use and don't?
Oh yeah, timestamps. Don't do it. Something like 80% of the reproducible builds problems are timestamps, because developers, they're like, oh, I want to know when this binary was built. Use build logs for that. Keep a log of your build logs. You should have some way of knowing this binary is, and not the timestamp, because if you take a piece of source code and you build it today, oh, I've got that timestamp. That tells me when I built it, but it doesn't tell you what the source code was. If you build that a year from now, you get a different binary. So number one thing, don't embed timestamps in your binaries. Just resist that temptation. It's an old practice. I know a lot of the core GCC and friends was reproducible in the early 90s, if I recall correctly. And gradually over time, people just kept injecting random stuff into it, like timestamps. So yeah, that's a good thing to do, but also just test it. Like, you know, build it on one machine, build it on another machine. Maybe one of them's got an Intel CPU, one of them's got an AMD CPU. Like, you know, embedding what instruction sets are used is sometimes done. You know, like just like try and introduce some simple variations, possibly use tooling like reprotest or something. Reprotest is not specifically Debian, it's largely used in Debian, but you can use it on other projects as well. As long as you can teach it, you know, a one-liner of how to build my project. But yeah, there's tooling out there, and we have an IRC channel that we love to have people hop in on and ask questions. And you know, we also have a mailing list, which might be better for a little asynchronous question. But if you have like a quick question, yeah, hop in IRC or get on the mailing list and just describe like, hey, I'm doing this. It's not coming out reproducible. Help. Yeah, that's a great question. Any other thoughts? Yeah. Usually it will take the old compiler version and rebuild it. Geeks has kind of, well, it's basically got a main development branch, and so everything kind of goes into that. But depending on the language or the compiler, you basically just build the new compiler, and then everything that needs that compiler will be rebuilt. Yeah, exactly. And in reality, a lot of these reproducible builds things, we're like 90% of the way there, but there are some really annoying cases like GCC that aren't always reproducible. Though some of those are with optimizations, like if you don't use profile guided optimization, it's a lot more likely to end up reproducible. I forget what some of the other things were. Like bin utils, I know how to make it reproducible, but the way Debian currently builds it, it's not. And that reminds me, we've cheated on our infrastructure. I should revert that so it shows correctly. Yeah, how about you?
How is kind of the historical artifacting managed? Because I know, at least when I started, everything was in SVN and SourceForge, and that was before the Git era. Are there projects related to or within Git to like record old like zip distributions or other things that are part of the bootstrapping, or is it everything?
Yeah. I think most of the stuff, I mean, mostly in the Geek sources, there's like a, here's how you find this tarball, and we use that for the bootstrap, more or less. In fact, the early parts of the bootstrap chain don't touch Git because Git has a lot of dependencies to build. So yeah, some of them just kind of take a shortcut like that and say, this is what we're using to start with. Yeah, and I don't have the full bootstrap story in my head for geeks, but I'm familiar with the basics. So yeah, does that address what you were thinking, or because yeah, 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 it has different backends. Yeah. Right. Yeah, I think there is even subversion support. Yeah, there are various different backends for geeks. So it includes a reference. Most of them are either Git or tarballs, but there are a few oddballs, like Frank was saying. But yeah, increasingly few actually. Partially because of they have such good integration with softwareheritage.org, which is another amazing project if you haven't looked that up. I would recommend checking out softwareheritage.org. They're basically trying to archive all free software on the internet. So they're that internet we wish we had 20 years ago. So because there's such great integration there, there's a really strong push to even build packages in Geeks just from Git because we have such a great backup plan for Git. So yeah, I've definitely encouraged that because it's like, well, tarball, that's kind of hard to actually maintain and reproduce. Although disarchive is a really cool project. I think they basically disassemble the tarball and then maintain some metadata about it, and then can recreate the tarball without necessarily having the exact tarball you had. It's pretty cool stuff. Kind of reminds me of Pristine Tar, actually, if you're familiar with that. Similar kind of project. Yeah, did you have a question, Frank?
What's the differences in the sizes of the repositories? How many packages does Git say Geeks currently have versus Debian?
Yeah, they're in the same ballpark. Last I looked, Geeks was like 20 to 30,000 packages, and Debian's like 30 to 40,000 packages. So that actually brings up an interesting question. Is like the differences in project structure. Like Geeks is like tens, maybe at best hundreds of active contributors, and they maintain like tens of thousands of packages, and not always perfectly, of course. Whereas Debian has thousands of contributors and they maintain tens of thousands of packages, and that's kind of interesting. And that kind of gets into the difference in the maintainership models between the two projects. Like Debian has a very strong maintainership model where like I am the maintainer for this package, and in Geeks it's kind of a little more like, hey, anybody who has commit access is responsible for uploading things to Geeks properly. They're gradually moving towards each other, though, interestingly enough. Surprise, extremes are not always great. Over many years, Debian has moved more and more towards team-based packaging, and Geeks has just recently introduced team-based packaging. So they're kind of moving in a similar direction, but they have very different history. And Debian has a lot of curious quirks just from being such an old project. There are things that if we were to do Debian again, it would just look very different, I'm sure. That was part of what I was what I wanted to highlight in this project. But yeah. Yeah, it's reproducible builds in general and Geeks specifically trying to achieve the same thing, essentially? Well, or yeah.
Why is Geeks doing it? Is it just sort of emergent from doing source-based builds, or I don't know if the question is well formed.
I don't know that I have a great answer to that. I mean, I know Geeks. So just the era Geeks was developed in, reproducible builds kind of started almost the same time. Geeks started in 2012, and the current generation of reproducible builds project, the current like active effort, was started in 2013. So there was a similar time frame, and also the Nix project that Geeks is kind of derived from. Deterministic builds were kind of a fundamental part of the design. So Geeks, I said it's a source-based packaging system, and that's true, but they actually kind of advocate that it's a functional package management system. So given these inputs, you pass it through this packaging function and you spit out these outputs. And like ideally a functional system, you get bit for bit identical results, and they do some things to maximize the odds of that. So like in the build environment, the username is normalized. They set some values that say, hey, build, use this for a timestamp. They do, they use a consistent build path. They do a lot of things to maximize the chances for reproducible builds by just having every build be similar. Whereas Debian, evolved. It started with people just building stuff in their home dir and uploading it to the repository, right? And gradually over time, we've gotten more and more sophisticated about it, but there are some like historical leftovers that we're still dealing with. that like just the other day, I dealt with this one. It always makes me feel so dirty. But I had a new package. It had an ABI bump. And so in Debian, you have to change the package name. Well, that means it needs to go through review rather than me just uploading directly. In order to go for the review, I have to upload the binary package, not just the source. And then they look at it, and then that ends up in the archive, and that feels so wrong. So this is a leftover from that era. Those don't ever make it to a testing release. Those packages are blocked from getting into the stable releases and that sort of thing. But it's like a relic of like, you know, well, this is the way it used to be, and we haven't quite updated the infrastructure to handle this differently. So yeah, there are things like that that just aren't an issue for geeks. Yeah, so I think geeks leveraged a lot of work in the Nix project that was really focused on determinism, and then in just the era it evolved in, you know, there were a lot of things that made it easier to do reproducible builds.
I was just going to add that they're also very involved in scientific research for scientific results.
Yeah, that. Very much so. Yeah, there's a very strong overlap with the scientific community, high performance computing. And so, yeah, there are people who believe in reproducible science, and they think computer science shouldn't be any different, right? We should be able to reproduce the results given the same information. So, yeah, I think, you know, both projects have like security teams, or, you know, you get like a security problem, it comes through. Geeks is pretty, I think, a little more informal, whereas Debian has like a process where like different team members rotate through who's handling the inbox, as it were. And they have like all sorts of formal infrastructure for how to go about doing a security release. Yeah. So these different projects evolved at different times. I would say they're both mostly trustworthy. They're both getting like around 90 to 95% reproducible builds, kind of, sort of, depending on which angle you look at it through, or if you're using a magnifying glass or a telescope. But so they're both achieving some amazing results. And Geeks has a much better bootstrapping story than Debian, which Debian basically has a sad story for bootstrapping, and Geeks has an amazing one. These projects have evolved over time, but they're still largely trustworthy, I think, because they're striving for these things. You know, it's not necessarily about full success at something. Security is always a matter of just raising the bar, making it a little bit harder for an attack, making it a little bit harder to just make a stupid mistake, you know, those sorts of things. And both projects are striving for that. Some with a little more baggage, some with a little fresher start. I love both projects, honestly. They're both pleasure to work with. But yeah, like the crazy thing that I realized, like, oh, it's actually kind of hard to debug a long build in Geeks because you have to start from scratch because they're so pure. Things like that are just, but it's also the right thing to do. So yeah, you shouldn't have to trust things. We're really working hard to move to where you don't have to trust things. You know, the old saying, "Well, trust but verify." I'm like, well, let's just verify, right? Like, let's just skip the trust part and let's like get our systems to the point where we can just verify it, because then the trust is implicit in the results. It's not, you know, I mean, I'm not saying we should throw out digital signatures and all that kind of stuff. Like, you know, somebody still needs to be responsible for what's in the project, and you're not going to find every bug. And, you know, a basic computer science exercise is to like, oh, introduce a bug in code that looks innocuous, and those are totally real, but you're never going to solve all of those, but we can solve some of these other problems. And so I think projects that are striving towards that are in general more trustworthy, and they have a process for dealing with when things aren't quite right. So yeah, any more questions, thoughts? Yeah.
What are some of the big rips in the space?
I stare at GCC and cringe because that's like a compiler used in almost everything. So I would really love to see that be reproducible. I know the maintainer in Debian is somewhat amenable, but also very busy. We did see some improvements in Python recently. I know they have like Seth Larson has had at least like made their source tarballs reproducible in light of the XZ attack and all that stuff. So things like that are pretty cool. There have been a number of other folks working on at least making your source tarballs reproducible. Great work. So yeah, I don't know. Does that answer your question? Cool. Yeah. Well, I guess I think we're done. No, more or less. All right. Yeah. Thanks for coming. Yeah, and if you want to chat more, I will be spending a fair amount of time at the Software Freedom Conservancy table, and yeah, go get some good lunch.
I'm a little surprised it's such a nascent thing, given the work of the Software Freedom Conservancy and just in general the license obligations for source code licenses anyway.
Oh, that's a whole other. I gave a talk years ago at libre. I'm like, is it really open source if you can't prove it? Or is it really free software if you can't prove it?
Yeah.
Reproducible builds is one of the strongest ways to have a reasonably strong proof.
I think maybe part of the problem is that people slice and dice the language of things, even with the GTL3.
Yeah.
In terms of what does complete corresponding source really mean.
Sure.
It does not say you must provide a reproducible build. It says provide.
It doesn't say that.
It says provide the complete corresponding source. So.
Yeah, but the word complete is pretty leverageable there. If you can't actually.
Well, it's arguable is the problem.
Yeah, sure.
I've dabbled in like ARM microcontroller programming, and I run into stuff in GCC where you'll have shell scripts to set up a project, and the shell scripts don't have any licenses associated with it.
Yeah.
It's been passed around on forums and other stuff, where it's just like, okay, this guy wrote this. They wrote it like written by law, but there's no license file, nothing.
Yeah.
It's like, but it's code that does your environment, that lets you build a tool chain, but it's not the source code. The source code is just pulling down GCC and other stuff. It's a mess.
I have a question about that project with Python.
Oh yeah, the reprotest.
Yeah, so
Yeah.
I'm an intermediate developer. I don't know a lot of
What?
systems. Intermediate.
Oh, okay, got it.
I'm more of a systems guy than a developer, but I'm trying to get better at software development. And
Yeah.
I think if that would be a good place. I mean, I'd
Be happy to have you take a look at it and see if it's something you want to work on. It kind of made my head spin a bit when I looked at the code, but I'm not a terribly proficient coder. I do a dabbling of like, oh, here's a 4-line patch here, and here's a 4-line patch there. And it makes it pretty easy. Yeah. But the code base is all public. Yeah, you can look it up. It's salsa.debian.org, or I can just get an email.
yeah, an email.
Yeah. Yeah, well, just send me an email and mention the reprotest and I'll give you more information on that.
But yeah, I'd love to have your help.
And if it doesn't work out, that's fine.
Yeah, I mean, I'm not like
Frank introduced me to geeks, and when I was giving my talk, and I never heard of it before.
Yeah, it's
She's interested in software builds and materials.
Right.
A lot too.
So
And it's like, it's in the piece. It's all
So
there.
ostensibly, I mean, we were doing software build materials with the build info files since ages ago.
Yeah, that's one of the things.
And this
you
is
know,
like,
CISA
I
is
want-
CISA is so hooked into the software building materials, and it was so it's like they were surprised that
Testing, 1, 2, 3. Testing, 1, 2, 3. Okay, that looks good.
live? Oh, it's doing something. Okay. Well, I'm loud, so.
I just switched it so you're live on the internet too.
Oh, excellent. I love that. Okay. I guess everybody's here that's going to be here. So, hi, my name is Sen Hastings, and this is my talk, Code by Mail, which is, in essence, a rough and tumble guide to submitting to mailing lists. So the disclaimer is that this talk assumes you know a little bit about what an email is, I hope, as well as a little bit about how software is developed, specifically development with Git. Also, this talk is less about the what of mailing lists and more about the why of mailing lists, but I still hope that it can cast just enough light to dispel any fear that you may hold against them. Now, first, some history. I should say to preface that one of the people credited with the invention of electronic mail has expressed that while he kind of had his hand in it, the whole thing was sort of inevitable. And I mean, it's quite possible that it sprang up in multiple places around the same time, but for reasons that will become obvious later, I'm going to focus in particular on the work done at MIT starting in the late 1950s. You see, this sounds rather obvious at the outset, but in order for electronic mail to be mail, it has to be written by someone and addressed to somebody else. And in order to be addressed to somebody else, there must be somebody else, as in another person on the same machine. And that gets really interesting because early electronic computer systems were, in essence, modular electronic calculators where instructions or behavior was dictated via switches or plugged wires. So they actually required multiple people in order to set them up for a particular task in a timely fashion. Like, for example, the Pennsylvania Six, which were the original 6 female programmers who set up and ran the ENIAC to perform ballistic trajectory calculations. Actually, sorry, one more joined later and another one wrote the book. So I guess that makes 8. But that's not exactly it, is it? I mean, that's one computer that is being operated by multiple people. Where do we get to one computer operating for multiple people? Well, the answer is that first you have to design machines that can operate for one person, and then you have to make everyone take turns. The history at MIT, at least, seems to start in 1956. When Douglas T. Ross, who was working at MIT's Lincoln Laboratory, proposed connecting a Flexowriter, which is a particular brand name of electrically controlled typewriter, directly to the Whirlwind 1 computer. A few years later, in 1959, John McCarthy, creator of the Lisp programming language and the guy who coined everyone's favorite term, artificial intelligence, wrote a memo to PM Morse with the same idea, except this time we're going to do it with more than one Flexowriter, and we're going to do it on the IBM 709 that MIT was supposed to get in the fall of 1960. So they did some experiments, and those would later mature into the compatible time-sharing system, or CTSS, in the early 1960s. But what is time-sharing? Well, you could read the memo, or you could read the section Introduction to Time-Sharing from the second edition of the CTSS Programmer's Manual. But I'll summarize. Essentially, really big computers are expensive to run, so we usually batch all the programs together to ensure the computer is always occupied with work when it's running. At MIT, batches were created by taking a program, which you had punched out on cards, 1 card per line of code, feeding them into a card reader, which would then convert those cards into an electronic format and write it to magnetic tape. Once the batch of programs was written to tape, the tape would be fed into the computer, and the computer would summarily run and execute all the programs and print all the output. This would take several hours. The alternative to this was online, which is to say interactive programming, i.e. with a typewriter, and that's great for human productivity, but it's harder to justify on bigger machines where it would be an absolute waste of system resources. You know, waiting for key presses. So what if the computer spent just a little bit of time interacting with one user before moving on to the next, round robin style? And if none of the users needed anything, the computer could just spend time doing background batch work. This way, the computer would always be doing something, but the users would get quick service. This idea of improving productivity by increasing user action would form into its own project at MIT, Project MAC, and eventually deliver a second-generation time-sharing system, the Multiplexed Information and Computing Service, or Multics. Now, 3 parties were involved with Multics at the beginning. MIT, of course, Bell Labs, and General Electric. Bell would, of course, pull out of the project in 1969, and then, in the early 1970s, 2 engineers from Bell Labs, Ken Thompson and Dennis Ritchie, and I'm at a Linux convention right now, so I think you all know the rest of that story. Now, back to mail. Sometime between late 1964 early 1965, Pat Krisman, Glenda Schroeder, and Louis Pouzin published Programming Staff Note 39 for CTSS at MIT with the subject, Proposed Minimum System Documentation. What do they mean by documentation? Well, everyone seems to agree that system documentation, to the extent of listings, source files, and an index of what is in the current system, should be available to all users. The note goes on to describe methods for labeling, storage, and retrieval of documentation, and source code for programs, as well as a new proposed command called mail. The mail command. A new command should be written to allow a user to send a private message to another user, which may be delivered at the receiver's convenience. This will be useful for the system to notify a user that some or all of his files have been backed up. It will also be useful for users to send authors any criticisms. By the time Neil Morris and Tom Van Vleck were working for the political science department in the spring of 1965, the proposed mail command had not actually been written. So they decided to write it themselves. Their implementation had some slight differences from the original specification and was then documented in section AH.9.05 of the second edition of the CTSS Programmer's Manual. Purpose: to place a file containing a message to another user in his file directory, whether he is logged in or not. So we can learn a few interesting things from this, like the fact that users had private mailboxes that could hold multiple pieces of mail. Each piece of mail had an address line of the form from user problem number, user program number, the date, and the time. And there were two different mechanisms to mail multiple users at once. You could either do wildcards of the problem or programmer numbers, or with a file containing an arbitrary list of space-separated problem and program number pairs, with each pair representing a unique user. A mailing list, if you will. So there we have it. That is the history of the mailing list, at least according to MIT. And I could continue with this history lesson, but I suspect you all know like how an email in the present day works. So let's move on to the actual workflow of development using a mailing list. Okay, so step one is to open up your favorite text editor, then promptly close it. Because most of the emails you'll be sending to a mailing list aren't written. They are generated from your code. You can, obviously, depending upon the nature of the mailing list, also submit general questions. And we will touch on that in a little bit, but assuming that you're trying to submit code, we need to start with the code. First, obviously, get the project. This can be done in the usual way, or you can create a fork or whatever. But in any case, clone the project, make some edits using your favorite editor, add the files to your commit, add a commit message, and then commit. And here comes the magic part. We're going to pull down all new everything, and we're going to rebase our branch on top of the original development branch. And now we're going to run this weird command, which is going to return a file. And that file is our commit, actually. It's been pulled out as a separate file, and that's what we're going to send as an email. Like at this point, it's literally just like git send email to email address, name of the file. But before we do that, let's stop for a second and actually take a look at what we're sending before we send it out. So, lot of stuff going on here. Tell you what, we're just going to look at the documentation for git send email, for a git format patch, which is helpfully for preparing patches for email submission. Really well written name there. And we can see here documentation. It's a message in 3 parts. There's a metadata header, and then commit log message, and then the actual patch, which is like the actual code. And you see right there at the bottom, it actually says here, the log message in the patch is separated by a line with a 3 dash line. So if we actually go back to our message and we just pull out everything before the 3 dashes, we can see that this is actually the body of our email. And because our commit log is empty, well, aside from the little bit that got used for the subject line, it's totally empty. So we should probably, before sending our commit, fill out the body of our email with some sort of explanation as to why we're sending this patch in the first place. We should, for instance, probably explain like what file we're patching and also like why we're patching it. So let's rewrite our subject line to something more descriptive, like name of file, thing that we're doing to it. Now, for the body of our message, we're going to describe what the problem is, why it's a problem, what's causing it, and finally the solution, and maybe some examples or supporting arguments. So you could write something like this, which is a full paragraph, and I'm quoting some documentation there at the bottom, but if you chew on that a little bit longer, you might even be able to spit out something like that, because you need to remember that you're talking to a human being, and depending upon how well they understand the specific code and the coding language involved, you may be able to get away with a less verbose explanation. The burden of explanation may also vary depending upon the context. A simple 1 or 2 line fix to some code that you submitted to the project needs way less explanation than a giant patch set that rewrites huge chunks of the underlying system and could break compatibility with other stuff. See the real-time patch for the Linux kernel. Okay, so now that we've written a good commit message, we can send our email. But git send email can't send our email unless it has our account information, which of course is stored in our git config. You can edit this manually, add the send email flag, add more stuff under that, or use the git config utility. Okay. Before we do that, one of the cool things about a mailing list is that it's full of other people, and sometimes those people actually have the same problems that we do. And sometimes they've even fixed those problems as well. So actually what we should have done before anything is check the mailing list. Now, if you're already subscribed to the mailing list, which I hope you are at this point, go and check your inbox. But if you want a guaranteed way to filter your mailing list messages, I recommend filter by the list ID header. That obviously isn't going to help you search for messages that you don't have because they were sent before you joined the mailing list. So for those, you're going to need to go somewhere else. Now, mailing lists aren't like mail trucks. They aren't just a big place where you can store stuff. Mailing lists, by concept, are more of a decentralized collective agreement. You could achieve a mailing list by virtue of everyone CCing everyone back and forth. In practice, however, we achieve mailing lists by sending our email to one address, monitored by a service that holds the subscriber list and retransmit that message to all of the subscribers. The mailing list, in a very practical sense, is just every email that's been addressed to the service. And these services often archive those messages and make them available in a public way, like a website. Lots of these projects use GNU Mailman. The archiving thing for GNU Mailman is called Piper Mail, and the web pages usually look something like this. But theoretically, anybody can archive a mailing list by just, being subscribed to it and not deleting the messages. This includes other archive services, which are basically just subscribed bots. So kernel.org, for instance, operates an archive service at lore.kernel.org that not only archives all the kernel mailing lists, as one would expect, but also a bunch of other projects. There's also lkml.org. Mark is another one. Sometimes whole orgs will even just have a one-stop shop for all their project archives, like GNU, or actually Free Desktop even. And it's straightforward to use these things. You click around, you look for a search box, you search for the stuff you want. Once you find your email, you could literally just copy and paste the whole email to a file. What you should probably look for is actually a link to a raw or mbox file. That's just the raw email text. That's going to be easier to work with. Projects will also sometimes have a patch or issue tracker. And you can do the same thing there. So there's stuff like Patchwork. This is what BuildRoot uses. There's Track, which is what FFmpeg uses. And I mean, literally, this is what projects will actually tell you to do in order to get patches. This example is from the BuildRoot manual. Once you have the patch, it's really simple. You just want to do git am name of patch, and this will actually apply the patch as a commit. So if you're the maintainer and you do this and you like the commit, cool, it's a commit now, you can just push it and it'll be up in the project now. Or you can just apply it using the patch command if you want to. Now, I should tell you that there is actually another way to get patches, a more fun way, a way that involves the command line. All right, buckle up. This is going to be a bumpy ride, but trust me, it's going to be so worth it. Okay, so lists that use Piper Mail have a page of gzip text files by month. Just get all of them and cat them together. I wrote some JavaScript that does it for me. It'll do a list like FFmpeg, which has about 250 months of archives in 3 minutes. Then once you have your mbox file, which is just all the emails in one big file, you can just open it up with a command line email client like Mutt. I recommend enabling threaded mode. But what I would actually recommend is to use this other little email client called Alpine. It's my favorite. It was originally developed at, some university in Washington, I think, or something. I don't know, maybe you've heard of it, whatever. I recommend downloading the source for the latest version with the optional patches included and building it. It should only take a minute. Then just plop your mbox file in your local maildir. After that, just set up a filter rule in Alpine that moves all your mailing list messages to that mbox. Job done. That is unless, for some reason, the archives are messed up, which happens sometimes. Stuff doesn't get captured or things get duplicated. In which case, well, you remember lore.kernel.org? Lore.kernel.org uses the public inbox mailing list software. They have an NNTP service. Now, for those of you old enough to remember Usenet, you know where this is going. So we're going to make a place to store our mail. We're going to write a very simple slur and pull configuration to get all of the messages from that mailing list with no expiration, and then we're going to download all the messages. This is going to take a while. BuildRoot has just under 400,000 messages. This will take between 2 and 3 hours. So when it finishes, run it again to get all the messages that have come in the last 2 to 3 hours. And now we have a directory that has all of the messages in it as numbered, discrete text files. A lot of messages. And if you want to use Mutt, easy peasy. But if you want to use Alpine, we got to convert these messages to an mbox. So you just cat them all together, right? Wrong. It won't work. Why? There's no from line. From line? Yeah, from line. This line? No. That's a network from line, a colon from line, a 561 spec colon from line. Gotta get a local from line, on this from line, a mbox postmark underscore from line. What's that you say? It's the from space from line. We're gonna build a from line. We're going to use grep to get a date from the date line because all that they read is the date from the from line. Then you can cat all the mail to the mbox. But wait, let's mix all the mail. Got to go fast with a tool from a set. Take a guess, run it home, move across, make a drop. Not a box full of news. That's a full stop. I got almost 400,000 emails in this mailbox, and I can pull up any one of them. I can show you every single one that I ever sent in an instant. But that's not what I want to show you right now. Instead, I want to leave you with some final thoughts. So for starters, when you're applying, do not top post. You want to post, you want to post in line. And actually, better yet, remove all of that extra text. Nobody needs that. Remove everything except just a little bit of the email that you're directly responding to. And you want to make sure that the value of your in reply to header is set to the value of the message ID header that you're responding to. Otherwise, the email might not get associated with like the thread in the patch tracker that they're using. It'll show up as a totally separate email when it really shouldn't be. Next, you want to ensure that the patches you're sending are in plain text. So check your headers for stuff that looks like, content type text plain, US ASCII, content transfer encoding 7-bit. Set this in your git config with that flag. This is really important because then git send email will yell at you if you include non-ASCII characters in your patch. And this is important because if there's non-ASCII characters in your patch, your whole patch might be base 64 re-encoded somewhere along the route. Ask me how I know this. You can find this talk here, codebird.org/sendh code_by_mail. And I can only really provide you general advice. Rules and etiquette vary from project to project. Check the docs for a submitting patches section. Literally all 3 of these projects have the same section for it called submitting patches. And as a final note on that, understand that words have weight and tone, which is sometimes very difficult to communicate through text. This is on top of the fact you may be communicating to somebody in their second language. So for a totally excellent talk on intentional tone in emails, you should check out Strategies for Appropriate Social Interaction by Carmen McClellan from a couple of years ago. And above all else, be respectful. Because the double-edged sword, the pros and cons of mailing lists is that mailing lists live forever. 1,000 GUI git issue threads can slide into the ocean. Email servers can fall over. DNS records can crumble into dust. But as long as those bits are on your hard drive, you are on the mailing list. You are the mailing list. Don't ever forget that. But I'd like to thank a bunch of people who helped me with this talk. I'd like to thank SeaGL for this event, of course, and also to the University of Washington, not only for this venue, but also for the software packages, Pico, Pine, Alpine, which I'm using right now, IMAP Mix, and UW Mail-Utils. I want to thank all the maintainers and everybody else who contributed, and also my dear Aunt Carolyn for suggesting Alpine to me in the first place. I'd like to thank Neil Morris and Tom Van Vleck for email. And I'd also like to thank Tom Van Vleck for the wonderful website, multicians.org, of which my history section is but a crude summation. It is an absolutely invaluable resource on CTSS and Multics written by somebody who helped write CTSS and Multics. And finally, last but not least, I'd like to thank my main consultant for this talk, my dad, who turned 2 to the 6th this year, who, while attending college, not only did his homework on an IBM 360 batch system, but also on UCSCB, a PDP 1170 running a Unix time share system that anyone, and I mean anyone regardless of their major, at UCSC could get an account on. But that's it, and that's all, and I'm all out of time. But if you still have questions, you can send me an email.
How many times have you practiced the fast part?
You don't want to know.
Does your dad still have the P1170?
No. UCSC, well, is it UCSC? UCSC still has a Unix timeshare you can get an account on, but they are sunsetting it in 2025. I am actually out of time. I think they're responsible for IMAP. They're definitely responsible for Mix, and they're definitely responsible for a series of packages called UW mail utils. All of the associations with the University of Washington were not intended. It just sort of happened all of the sudden.
Wait, was that whole PowerPoint inside of Outline?
No, just a bit at the end. Just a bit with the emails. Thank you. Thank you all. Have a good one.
That is not what we want. Hello, sir. How are you? No, I know who you are. You're very distinct. Don't worry. You're very distinct. Even without the hair.
All right, so he put us live. I don't think I need to wait till he gets back. We're gonna get rolling instead. And if people can't hear me online, I should be able to catch it in the chat. So like, make some noise over there. I kind of move away from the mic and make AV people mad. So let me know. All right. So yes, I am Dr. Kaylee Champion. Woohoo! Because I'm so excited to say Dr. Kaylee Champion. Those of you who know me or at my talks in the past, I haven't always introduced myself as doctor because I defended my dissertation in July and am now official. So I even have the t-shirt that says, not that kind of doctor, but I can take a look. So, so be careful with the questions you ask. There's some things maybe that I don't want to know about, but so I have a talk, and if you've been to my talks before, you know I try to load in some of the latest research findings, but there's some things in here that you've probably seen before. So if you don't have questions about this, we can also just play research vending machine. This is a great game I love to do, which is people ask me questions like, what does research say about X? What do you think about Y? And I may or may not know anything. I promise not to lie. But there's tons of really cool research on so many topics that I cannot fit into a coherent story. So if you have those kinds of questions, we can have that kind of discussion. My favorite thing that isn't in the talk, I just happen to love this finding. Someone studied the differences in how people write code when they're committing to sort of dirty repositories, bad code full of errors, just kind of messy, lots of tech debt. How people commit to dirty repos versus very clean repos. And it turns out the same developer writes crappy code when committing to dirty repos and clean, beautiful code when they're committing to clean, beautiful repos. Same person. So this is the kind of thing that these fun, like research findings, like, okay, that's interesting. Maybe it's worth cleaning up those darn warnings because other people actually follow suit and write better code because of it. I just think that's interesting, cool, the kind of perspective you might not get without a research orient or a quantitative view, a broad view of what's going on in our communities. All right, so totally irrelevant to what I'm actually talking about. Great, but we can play research vending machine if you want to. Awesome. So what can research tell us then about building, leading, and sustaining open source? We're gonna do a little orientation, we'll talk about challenges, and then we'll talk about strategies to respond, and I'll hope to give you takeaways as best I can. So this is a photo from our recent research retreat. I'm a member of what's called the Community Data Science Collective. This is folks at University of Washington, at Northwestern, at Purdue, and at UT Austin. We get together and work on research projects. We hang out on the same IRC channel, and we all do research around kind of taking social perspectives on online communities. My favorite online communities happen to be those that produce open source, but folks also study Reddit or gig economy, different kinds of online communities, not just free software. Even though they should, I think they should all study free software. So this is the cool stuff that I get to study. This is software that really serves, I think, as digital infrastructure, even if folks don't immediately know every logo, although probably the people in this room do, they certainly know what they get out of it in terms of digital infrastructure, serving the things that we use and do every day. The world runs on open source software, as we know, including academic research. So how do academics use open source? For one thing, it's a subject and an object. What I mean here is that it's a tool. We use it like everybody else in everything that we do. We use it as a setting, a place to study things, and as a data source. We ingest that code, and we ingest data in Wikipedia. We ingest things that go on in open source straight into our own projects. We study open source as important in its own right because it is important in society, as well as kind of a way that we can study other kinds of social and technical questions about how we might organize or work together as people, how we can collaborate better, how we can organize in better ways. But research then owes a lot to open source. And putting research into practice is sort of a challenge. It doesn't necessarily even connect in certain ways. So thank you for being here. I feel like this is part of how we bridge this gap. We talk about what research has found, we talk about what we know from our own communities, and we try to reach kind of across those gaps. So I feel like this session is actually part of that, and you're contributing just by being here. All right, so what can research tell us? We talked about kind of getting oriented and this research record. Now I want to talk about the challenges we face. And I feel like a lot of these will be very familiar, but it can be helpful to know that you're not alone in having these thoughts and that there's sort of a broader kind of context we can plug this into before we talk about responses and takeaways. So we all know that free software is a lot of work. Scaling up is really hard, and community might not have been our original goal when we first put something onto GitHub. Were we planning to found a new community? Maybe not. Like maybe we're just trying to write code and live our lives. We talk about free as in beer and free as in speech, but there's also free as in puppy. So just because I pet a dog doesn't mean I'm opening a dog sanctuary. I mean, I love dogs, but I only pet the dog. I'm not trying to open a dog sanctuary. User support can be a real strain, and this is something that I think a lot of folks don't always appreciate, is the effort that can go into supporting users, especially when you're not paid for this as your day job. But events like this one have been really shown to build trust, to improve teamwork, and to make the whole experience more fun. If you need more backing for how these events are important, happy to help with some of that research. Another thing that comes up in research people do is we talk about catastrophic success. This is sort of tying back into this question of free as in puppy. What happens when the thing that you never planned to go viral goes viral again and again, and now people say, you know, all the puppies will die if you don't continue to support, you know, my left pagination library. What do you do at that point? One of the solutions that have come back from these kind of interview studies and the experiences of other folks is simply automation. Automate, 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 which is great. We all want to replace ourselves, or at least our enemies, with shell scripts. All right, so unfortunately, it turns out that some really critical parts of the software that we use and maintain can be neglected. And both the left pad incident and CrowdStrike over the summer kind of really remind us how interdependent we all are. In the sort of massive airline shutdown that happened in the wake of CrowdStrike, I was doing my dissertation defending it, and no one in the room needed me to convince them of the interdependence that we all have. Even though CrowdStrike, not our fault. Oh my gosh, thank you. It was not open source's fault, and I was really glad to see that one. Because there's some vulnerabilities like Heartbleed, like Log4Shell, where, okay, open source maybe gets a little more implicated. But they indicate what I call misalignment in my research. So this is where thousands of really important packages that are out there, heavily relied on, are unfortunately low quality. And this misalignment risk, where something's quite important, but the quality's way down here, we're kind of out of sync, it increases with time. I've studied how this sort of evolves over time, and it turns out older packages, things written in older language, more likely to be subject of this neglect, which I think really resonates. So sort of maybe what we'd expect. However, this risk also increases with greater numbers of contributors. So one thing that one person and their like committed friend have been working on for a long time, that might do better than something that a lot of people have pitched in over time. Maybe they zoomed past and kept going and didn't engage in the same way. So just getting more people involved, not enough. It might actually harm our projects. You know, it's kind of uh-oh kind of moment. All right, so we got through this part. We talked about how efforts can be misaligned, important communities can fall apart, and super important software can be low quality. All right, now I've talked about all the bad stuff. What are our strategies to respond to this before we do takeaways? All right, how do we counter this misalignment that I talked about, and how do we build sustainable communities where this very important software is equally high quality? Because it turns out that a sustainable community, that happy, friendly, lovely place that we might want to live in, it can produce popular but very low quality software. We can feel great about the community we're in, and the work isn't guaranteed to be great. And that's a problem, right? Because we were sort of hoping, I think in the initial lines of community research, that if we could get the community right, that the software quality would follow. It doesn't necessarily happen that way. Great software, in addition, might not outlast its maintainer. We're all getting old. The internet is old. All of our kind of patriarchs from the past are also getting old. How do we have our software actually outlast the maintainers who brought that to us in the first place? We need both strong communities just to survive and the alignment of importance and quality, that great software that folks rely on. At the same time, we need both. It's not enough just to feel great. We have to do great. Thank you. So how do we get there? First step, I would say, is with awareness. You know I have a 50-minute slot, right? You just gave me a 10-minute warning. I'm like, whoa, I'm about to go fast.
Another 20 minutes.
No, I got 50.
I was wondering how you were going to get.
I know, right? You're like, oh my gosh, how's she gonna get there? Talks
It's
so
a very
fast.
long 5 or 10 minutes.
Yeah. I haven't got Sen's delivery though, because he's got it jamming through. All right, if you're here at the last talk. No, it's okay. I'm good. We're all here. So how do we get there? Let's talk about awareness and intervention. I feel like there's 2 ways we can think about the problems that we're facing. We can think at an ecosystem level, everything in Debian, everything in Python, everything in Apache. Or we can think about the life cycle of specific projects, specific products that we're involved with. Those are sort of 2 strategies we could take toward analyzing a problem like this. But I think whether you're looking at a whole ecosystem or a single project, there's 4 steps to follow for this alignment question. You want to find a way that you can measure the importance of what's going on with your package or your ecosystem. You want to find a way to measure quality or security, the things that you're concerned about. You want to specify a relationship, and you want to measure deviations from that relationship between quality and importance that you're hoping for. And one thing that makes my approach to measurement and to research maybe a little bit different is I try to never say, it depends. It depends. I hate that. I hate it depends. Even though it usually does, I try to avoid it because what people like to hear, like to know, is some kind of baseline, some way to actually set a sense of if they're doing well or doing poorly. So my work is really trying to bring that level of specificity to things I find. And what that means is a little bit later, I'm going to be naming some names. And I don't want anyone to feel bad because I love open source. But if we don't name names about where our struggles are, we can't get better because we can't prioritize our work. All right. So here's a worked example of this process, these 4 steps I talked about in action. This is from the last project in my dissertation. Woohoo! I'm still going to dine out on that for a while yet. So this study, I looked at the number of installations of software packages in Debian. I looked at software written in Python that's distributed by Debian, and I measured every version of every release that was put out over time. And I looked at errors per statement in Python, measured through Pylint. And then I looked at the alignment of importance and quality, as I was talking about before with kind of the step 3. And then I looked for gaps and slopes where there's problems in the successive versions and sort of assessed that. So I talked about looking at everything in Debian. We have these 4 steps: measure importance, quality, security, relationship, deviations. So for importance, I'm looking at, this is from PopCon. Look at how nice Debian is. They tell me how many times different things have been run. It's beautiful. There's actually not as much data about how open source is used compared to, say, downloads. Actual usage data, which is what we can get from Debian, is beautiful. I mean, the graph is a little ugly, but the data is beautiful, which is where my heart is. Pylint's great, right? It gives you a number. It gives you some measures. It tells you, hey, you violated PEP8 in this way or that way. I'm only using an error per statement count. I know we can feel differently about the specifications around PEP8, so I'm only looking at errors per statement. I feel like we can agree that errors are a bad thing, even if we don't really care some other of the picky elements of that. All right, so now we've got a sense of importance. Thank you, Debian. A sense of quality. Thank you, Pylint. We're going to specify our relationship. What do we think that relationship should look like? This is kind of my classic schema for the relationship between quality and importance. If you haven't seen this graph before, what I have here along the left side is just relative quality. The high quality stuff lives up here. The low quality stuff lives down here on that y-axis. And then on the x-axis, I've got relative importance. So as something gets more and more important, it's going to live sort of higher values here. So by risk condition, the place I don't want to be is high importance, low quality. If my quality and importance are matched, they're in this alignment condition. And when they're out of alignment, or when the quality is quite high but nobody's using it, which is maybe okay, we're kind of in this higher zone up here. All right, so that's kind of my analytic schema. Now that I've got this, I can make measures and really dig in. All right, oh, that's backwards. we should go forwards. All right, so this is maybe a little bit harder to read because it's got more data on the slide. But what you see here, that same scheme where I'm showing along the left, I've got quality, low to high, and importance, low to high. And now I'm naming names and I'm talking about things that are relatively important, widely installed via Debian, but fairly low quality on, sort of compared to that importance. So everything that falls below this line, we're a little bit out of alignment. So what's here? There's some interesting stuff here, and some of it maybe we care, some of it maybe we don't. Do we care that GNOME Sudoku is out of alignment? Well, probably not, unless somebody puts some kind of terrible, patch into it that decides to farm Bitcoin while you thought you were playing Sudoku. Maybe you don't mind that the quality there has been slipping, even though everyone apparently is still running it. But for something like UFW, which is for firewall maintenance, or NTPsec, these security tools, we might be more concerned that quality has been slipping, but importance is still going along like crazy. So we can start to kind of see where things are and maybe prioritize our efforts if we want to seek out new funding, we want to seek out new maintainers, seek out additional help. At least we can kind of prioritize against the vast rafts of software that are out there that we could be working on. All right. Another way we can think of things, though, is we can think about life cycles. As our technology grows over time, changes over time, our concerns about it might really shift. So here, I've normalized the units so that everything's vaguely comparable, and I've got importance in orange and quality in blue. And so the story we can tell over time is something like, okay, I'm committing, the quality's getting better, and then I got bored, and then I put in one more patch, and then I walked away. We can sort of tell a story from that process over time. And we can tell a story, too, about the importance. So at first, everybody's super excited, and then maybe they got less excited because I quit working on it, and then they all migrated away. So if we take this sort of life cycle perspective, and then we think about how the life cycle of development is lining up with the life cycle of users out there, we can start to identify points of risk or periods of risk. And that's great for research because we can say, well, what happened at the point where these divergences start to happen? And what kind of interventions, what kind of changes can we make in the environment that will bring these things back toward alignment? What happened to make these things occur? So that's where some of this sort of life cycle perspective comes in. All right, so these are those same life cycle views of those 9 that I showed you before. And we can retell the story of some of these packages just by tracing these. And I was sort of calling out NTPsec before. NTPsec is very up and down, but lately maybe a little more down, whereas usage, still really climbing. That's in orange here with quality in blue. What we might look at something like list changes, which is sort of an internal tool within Debian, right? So it's kind of flattened out here. Usage still climbing, maybe we're less concerned there. We can look at these gaps and start to interpret what we see and start to prioritize our work a little bit if we can trace how this is happening. What else? Oh, I also called out PackageKit earlier when we're having a discussion. So PackageKit used as an interface to packaging, and maybe with Snap and Flatpak, people don't care as much about PackageKit. You can think about, okay, how are we maintaining some of that infrastructure for infrastructure? How are we keeping up not just the bridges, but the machines that fix the bridges? How are we maintaining things like PyPI? How are we maintaining things like Debian, like PackageKit, that are the underpinnings of the world that we live in? All right, so this is some of that kind of longitudinal view. Yeah?
Where are you getting the data to make these graphs, or how are you drawing these graphs?
I made this data. So this is sort of my research project. So this isn't published yet. You get a preview of what's going to be published in a journal. But each one of these sort of dots or wiggles are from 2 sources. One is I got data on usage or importance from Debian's opt-in survey tool called PopCon. It's lovely. It runs on your server and it tells people what you're using. This is great data for the usage of open source, but we don't have it for a lot of other settings. The data on quality I get by cloning every version of that particular software package that exists and then running an analytical tool against it. So now I've got a longitudinal view of usage over time and quality over time. Actually, I got the versions for this because it's from Debian. I got the versions of this software from Debian itself. So Debian downloads packages, redistributes, and they keep everything on a system called Solstice. I use Pylint for the quality measure. Yeah. But you can think of analogous tools for different languages or what have you. Right. Sorry, did you have a question too?
Oh, I hope you found a way to automate that.
Yes, I have scripts that write scripts. You know, you sort of, because, and I have these YAML files. I mean, we could talk about the crazy architecture of my, like, wacky system. But yeah, you always automate these things. You automate all the fetches, because you have to be able to do it again and again. I submitted this out for review, and I used originally the combo score that comes back from Pylint. People are like, hey, I don't like the way Pylint does this and this. I'm like, oh God, you're right. So I had to switch the entire measure and run the whole thing. So it's just over again. So it's just a one-line change, and then I run the whole pipeline, that kind of thing. Yeah.
What does Pylint's graph look like?
Oh, that's a good question. I was working within, I only used one version of Pylint on everything so that I had a consistent measure. But absolutely, that's certainly a tool that's that deserves to be studied. Yeah, it's a good question. I like that. But this is the same version, run with all the same command line arguments over and over again. All right. So I talked a little bit about the problems and about ways that I think we can intervene or learn about those problems with build our awareness. But then the question is, how do we intervene? How do we make things better? Folks talk a lot, especially in open source conferences and in academic research, about newcomers. We talk a lot about funding. We talk a lot about governance, how we make rules, who makes the rules, who's in charge, how do we decide. All those kinds of things go under the heading of governance. I feel like only academics call it governance, but I think we talk about who makes the rules, who decides, all the organizational stuff, as well as just how do we organize our work in general. So there's tons of citations on these slides. I'm going to post the slides, so don't worry about being able to read those, but I want to make sure that they were up here. So lots of people study newcomers, and they're necessary for projects to be sustained. We sort of know that. It's obvious. We got to bring people in. People come in, people go out. They can be recruited. Actually, causally, this has been demonstrated with social media. You tweet, you get people. Okay, great. You can tweet and get people. And you can direct them about where to go. You can put the time in and say, tag a thing good for newcomers. Newcomers will pick those up eventually. So you can tag, if you can sit on your hands and not fix the bugs that are good for newcomers, newcomers will eventually fix them. But it turns out these newcomers are not enough. I mentioned some of this a little bit earlier, because it turns out, inconveniently for those of us who love newcomers, it's experienced folks who really make the difference in sustainability. Damn. It's not necessarily the news we want, because how do we manufacture experienced folks? We got to bring in the newcomers who might not pay back a dividend. We might be training up somebody else's dream contributor in the future. So that's part of the aspect, I think, of how this sort of serves a community perspective rather than necessarily our own specific project. So those newcomers that we recruited via tweeting, they might or might not end up actually sort of rescuing our project, because the sustainability is more about these experienced folks.
Can I ask
Research. Yeah.
What paper was that in? You said that finding, or was that from your research?
The experienced folks, no, that's this particular one, this third one on the slide here. This is one of the most recent ones that I've added to this list here.
Okay, cool.
Yeah, how early participation determines long-term sustained activity in GitHub projects. So that's that third one there. And yeah, that's from this year. All right. Another major intervention challenge is all about funding, as we know. And unfortunately, it turns out a lot of these very large umbrella organizations that we love and rely on are starting to show some flatness or some decline in their growth. Others, new ones, smaller ones, may be growing a little bit more, but they did a survey study of a dozen different large umbrella orgs, like Wikimedia, like Apache, like Debian, all of these, unfortunately, showing some signs of kind of flattening activity levels. So that's a sign of concern, I would say, or a source of concern. Some of the research done on sponsorship, things like GitHub sponsors, have shown that that particular mechanism, that kind of one-off, onesie-twosie individual approach, doesn't seem to help a ton. Maybe tweeting that you need money might bring in some money. There again, yay, social media. And they found a number of ways that paid contributors can really contribute differently than volunteers, especially around large or more sustained efforts. There's some new research lately talking about how to spend funds, how people spend their money, event and travel, hosting like machines and so on, and CI/CD, kind of those pipelines, are a common approach to spending. But I'll mention this again a little bit later. CI/CD is like a double-edged sword. It's a little bit dangerous because a lot of projects are reporting back the first time they needed money for their project was to pay because they went over the CI/CD threshold. They went over the free level, and now they need to pay for something, and they never needed to pay for it before because they've invested in this continuous integration, continuous delivery pipeline. It's eating up a lot of environmental resources. It's eating up our pockets, and actually, it turns out what's driving a lot of those increases in costs is dependency bloat. And a lot of that dependency bloat is being driven by CI/CD tools. So who's pocketing the money from the bloat from Dependabot? Who's pocketing that money? We know who's pocketing our money. So I think being very careful around what we choose to spend our money on and how we invest in CI/CD is a place to be wary. There's some new models emerging around funding. If you haven't heard of any of these, the National Science Foundation has this thing called the POSE program, where essentially if you come to them with like a 2-year shovel-ready, here's all my security bugs, I need money kind of a plan. If you've really got your act together and can come to them, that's where POSE can step in, trying to help support big ecosystems. Alpha Omega from the Linux Foundation is another funding mechanism. Sloan is offering this digital infrastructure initiative. Germany's Sovereign Tech Fund. I was so pleased to be able to help the German sort of Sovereign Tech Fund come up with their schema for thinking through importance versus quality. And this particular perspective, I think, resonates really well with that kind of national sovereignty perspective on technology. If you haven't seen what the Germans are doing, trying to spread that further in the European Union. All right, third intervention challenge. We're doing okay on time, I think. Turns out if we study how people behave versus the rules that we document in open source communities, we don't always follow our own rules, sometimes to our detriment. Another interesting finding here, this is from work I did with my colleague at Northwestern, Matt Gann, and here what we found was that formality, hierarchy, rules, all those things that your project manager at work really wants to put into place, turns out that does not improve the sustainability of our projects. Instead, what improves the sustainability of our projects seems to be things like sharing power, which we're good at, which we know how to do. Sort of have to let open source be open source rather than have these sort of external models imposed without asking questions. So this is an interesting line of research that we've been digging into lately. So that sharing power seems to reduce the risk from things being neglected over time. Also, my colleagues down at Davis have found that having more policies on a particular topic does not seem to correspond to more effort on that topic. So no one loves rules, apparently, in open source, but doing more to document exactly how people should do certain things does not seem to actually encourage them to do more of that. So the beatings will continue until morale improves, and the policies will continue to come down until you are willing to work on the topic. All right. And in general, finding that, as we might be not shocked to hear, reporting can be burdensome, especially around these projects that are struggling. They may only have sort of enough time to sort of actually write the report and not get the work done. So as projects get to a state where they're struggling, there becomes a kind of a lockup, a vapor lock sort of situation. All right. Fourth challenge, this is my last one, is just around how we organize our work. So I talked a little bit before about automation being helpful, and then I talked about CI/CD being costly. So dependency bloat, often driven by Dependabot, is a real issue here and one to be aware of. It's important to continue to sort of document those decisions. Those mailing lists are there for a reason, and the acceptance criteria around really long projects, it can really slow down our work if we get to the end of a 2-year project and everyone's like, wait, what did you just write? You just refactored. What? none of us remember what we agreed to back when you guys went off into your sort of separate repo to do this. Another finding here, some people kind of laugh at this, review then commit, turns out it slows pace down of getting work done. Just make that pull request, just send it in there. There are some communities where the typical norm is that you all talk about the code that you've written or that you're going to write before you make that, before you do the commit, before you make that pull request, before you put it out there. You sort of review before you get it out there. You really are better off just going ahead and committing code and reviewing it post-commit. Maybe don't merge it, but certainly review it post-commit. All right, so those are our areas of intervention. Now I have my call to action before I sum up. So I hope I have demonstrated the value of collecting data and the value of having a plan to use it. I've talked about minimizing toxicity, talked about valuing our fellow contributors. All right, so we talked about these logs and records. One of the things I want to highlight here is just that if we don't have kind of the historical interpretation, we haven't explained our data, it can be hard to use downstream. So I ran into this recently where it's something like, oh yeah, why is there a spike there? No one knows, no one remembers. Let's talk about it. Let's sort of document when we change our infrastructure, when things like that happen. Engaging with metrics communities and researchers, I think is helpful. An area of action. I'm here from the Community Data Science Collective, but I'm not the only one that cares about metrics. The Chaos Project from the Linux Foundation also really cares about metrics. They've got tons of research and activities going there. I also want to encourage everyone to kind of open up their communication channels between users and development communities to talk about quality, not just security, but certainly also security, and talk about importance. And I feel like importance is the one where we don't always have as good of data. We don't know how our stuff is being used. We just sort of put it out there. And it can be lovely and very private and secure. It can be a complete mystery, but it turns out if we don't know how important something is, it can be quite hard to know if our quality suffering is actually making a difference to anyone. And it's hard to make that case, fund me, help me, support me, if we don't know if anyone's using our stuff. All right. So I mentioned minimizing toxicity, and research project after research project is really demonstrating how toxicity matters. This is something that we found that toxic comments will drive people away, scare off those newcomers who are investing in and hoping to bring into open source somehow. Experienced contributors these days look for toxicity and avoid joining because of it. Maybe once upon a time, certain people could get away with certain things that everyone else has decided they're done with. So if you want those experienced contributors, you need to clean up the toxicity in your community so that those experienced folks actually want to stay. We have a choice. There's people lined up out there to take my free labor. You know, why would I put up with that over here if people want me over there? All right, so the data comes back again and again. It doesn't make people better to treat them badly. Shallow and disengaged and toxic code reviews, in particular, not only wasting people's time, they just drive folks away. And emphasizing that shared goal of the project, the positives around here, things you can do, maybe counter that toxicity that you might steer into by accident every now and then. Emphasizing that shared goal of the project, having a shared vision, where you're trying to get to. You may not agree about anything else in the world, but if you agree what vision your project is heading toward, you can drive away some of this toxicity. All right. So I mentioned before, these focused code contributors, experienced folks really build sustainability. But it turns out that non-code contributors, who can sometimes be a little like unicorns, like we can't get them, and we imagine them as being able to do everything. A lot of times those non-code contributors are very wide-ranging. They participate in a lot of different projects. And those folks also drive sustainability. So you're not necessarily looking for a non-code contributor who's never committed to anything else on GitHub. You're looking for folks who are sort of sampling all over the place, involved. They've got their networks out there. They know how things happen here and there. They can write documentation that sounds more like documentation over there. They can help tie things together. So there's a different way of valuing non-code contributors and folks who are a little bit more casually participating. You don't need them to just focus and live inside your community. All right. And there's some research here too that talks about how good maintainers have technical chops. That is the table stakes. You still need great technical skills, but great maintainers, to go from good to great, you need to be able to communicate. And that's really what distinguishes folks. Finally, the retaining people in the community over time, that can really help fight this misalignment of quality and importance that I talked about before. So I have a little example for my old 4-step piece here. I might have enough time to get through it. I studied this particular question in the context of Wikipedia. So not in free software, but there's a lot of analogous things between Wikipedia and free software. It's a different place to study some of the same questions, a lot of the same ethos and the same contribution patterns exist in Wikipedia as exist for us in free software. So here I used for my importance measure, readership, people reading the articles or not. For quality, I looked at whether or not those articles are complete. Are they short or long? Are there links? Are there images? All those things. And then what kind of a relationship we want, same as in the other schema. Highly read articles, we want them to be great quality. Things nobody ever reads, maybe we'll live with it if it's not great. We want to measure those deviations when we're off that axis of alignment that I talked about. And this graph is a little bit hard to understand, so let me explain it. Because what it demonstrates is that people change over time. And if you're a social scientist and you hear people change, you get very excited. So my inner social scientist always gets excited, and I want to communicate that excitement to you. Because it turns out, as contributors to Wikipedia gain more experience, instead of working on whatever thing they started on, they start to work more and more on those low quality, highly read articles out and sort of for the good of the public. Over time, as that experience sort of grows, they're more likely to pick up the tasks that serve the public good rather than their own personal, say, curiosity. And this, I think, tells us something important for free software too. The more we can retain our contributors over time, they're more likely to pick up those tasks that aren't getting done, that need to be sort of done for the good of the public in general. All right. So we can trace even their trajectories over time and look how they select on different things. I don't want to get into too much detail there. And just to sum it all up, as we know, building and maintaining free software is a huge endeavor. Critical components can be neglected. Communities can be very hard to sustain. It's a lot of work. Aligning our efforts with public needs, I think, deserves focus. And formality, extensive reports, incautiously seeking funds and newcomers everywhere, that might not actually help us. Instead, we want to gather great data, we want to share power, we want to minimize toxicity, and encourage one another. All right. That's where I'm going to stop, and I hope people have questions or things they want to talk about before I go any further. All right. Yay, thank you. Thank you all. Sorry? Perfect. Thank you so much. Hi.
I have two questions that are related to Pylon.
Okay.
The first question has to do with Pylon is very flexible in its rating ability, and many software packages have different standards by which they hold themselves, and those standards may change over time. How did you accommodate for those differences between projects?
Yeah, so I ran the same flags on Pilot, the same version of Pilot against each one of these projects as it existed in the repo. So I did not accommodate different projects' preferences in that model. But I will say what I did do is the models that I fit included a variable for kind of project culture that will soak up some of that variation. So I could go into the statistics a lot, but I will say that when I fit models for this, I accommodate that not by tweaking the way I call Pylon, but by saying, okay, each project is going to have its own special flavor, and I'm going to give a variable to soak up that variation and just trace the general trend independent of local to project variation. So happy to go into the modeling for it, but that's how I accommodate kind of those cultural differences. Is by running the same analytical tool over and over, but then soaking up differences based on based on having their own per project variable.
So each project had a per project variable that had to do with accommodating the differences in standards.
Yeah. So you can build models that allow you to say, like, what's the general trend given that everybody is sort of different in their own special way. So that's the approach I took. Because otherwise, unfortunately, things won't be comparable across any multiple body of projects,
Then
right?
You're
Like
suddenly comparing apples and oranges instead of
right.
apples and apples.
So you sort of have to impose like an appledom, but you want to trace that. You still want to trace that variation and not get kind of and not sort of steamroller over it. And I did that essentially using statistical techniques.
Well, thank you for explaining how you accommodated that contradiction.
Yeah.
So the piece that, great talk by the way, the piece that stuck out to me is like how to figure out the importance. And I was wondering because it feels like one of the things that we always do in free and open source software is like you can use it for any purpose. We threw it over there, go through the dumpster, we're not even looking, whatever. Kind of,
right.
And then, but like, I feel like if I'm like, hey, Python's gonna put a camera by the dumpster, everyone would be like, whoa. Like, do you know the way that people are doing this that feels non-intrusive to get that kind of information?
Yeah, it's a good question. So some folks do it with things like GitHub stars. Other folks do it with things like download counts. I do it with, when I was looking at Debian, I'm doing it with installation counts. Each of these are sort of a proxy. One of the other kind of emerging ways that people are doing this uses dependencies or transitive dependencies, thinking about how different things depend on each other to build those importance measures. So there's, I guess, for projects to opt into, the SCARF approach or the things that Chaos is doing are the two that I think are kind of out there the most.
Oh, so we get like how much usage, but like not necessarily something on like what kind of usage. Like we just have a lot of data analysis tools, and you could use it to be like, who likes my song on, whatever.
Right.
And you could also be like, how many pieces of dirt are falling into the nuclear reactor? Like, we don't know.
Right.
It could be the same little data crunch. I have no idea.
Yeah. The other way you can sort of do that is by scoping yourself to an ecosystem where everyone sort of agrees that it's important in some way, right? So if you're like, okay, I'm studying things that get cited in scientific papers, they're at least as important as we think science that gets cited in papers is, That's why I choose software distributions as my kind of sampling criteria, because then someone has decided this is important enough stuff that we package it, maintain it, spray it out in millions of copies all over the internet, and then use it to run the cloud. Things like that. So life safety versus non is another thing that people would use. Certified to sell to the DoD or not. There's all different ways that you might measure that kind of importance, but it is part of the secret sauce of this, I guess, why this is not just a matter of kind of turn a crank and the research comes out, is you're making decisions and choices about how you do things, how you run Pylint. You decide, errors per statement matters. I'm imposing a normative claim right there. I think errors per statement, I do think that matters, and I'll stand here and you can throw tomatoes at me, but that's part of what you do when you do research is you have to take a stand and then defend it and win or lose. Yeah, other questions? Yeah, it'd be great.
The one with all the red dots and the line.
So many dots, so many lines.
So many dots. It looked
So
like
many
there
dots.
was a really dense cluster, and I'm wondering, did I get the axes wrong in my brain? Or?
Oh, yeah. No, I'm sure not. There's definitely some dense clusters on here.
Yeah, it was mostly all at the top.
Yeah. It is a ways back. So what this particular graph kind of does is we're looking at the way that I made these things comparable to each other. Almost. There we go. Okay, so the way I made these things comparable to each other, totally. So this is a snapshot from sort of today, or sort of most recent. And the way these numbers are scaled along the axis is comparing them to themselves. So the best they've ever been quality-wise, and that's the other way, I guess, by statistical techniques, I'm accommodating the project's nature, is that it's not compared to what I think is good software versus the good software over there, but I'm only comparing myself to me. So it's how good I was 2 years ago versus how good I am now. And my very best days could be ahead of me or behind me. If my very best quality is actually behind me, but my importance is still sort of shooting through the roof. 2 years ago, we had great errors per statement, but now it's, incredibly bad. That's a quality problem if usage is still really climbing out there. So the reason there's a cluster at the top there is that's quality for a lot of these projects. Today, their quality is the best it's ever been. And some of that actually comes from a quality measure in particular, because if you're looking at something like errors per statement, once you're at your very best, whatever that is, if you just stop updating, you just cruise along at that level, right? You're sort of static. So that's sort of the nature of quality, is that one way that you can lose quality is by continuing to maintain a package, which is, I want LS to not change, so I'm okay that it doesn't get a lot of, thank you, that it doesn't get a lot of commits and changes. But if there's new uses and involvement with new kinds of use cases and new users, then it might be a problem if it isn't changing. So, other questions? Yeah, Bri.
Do you think there would be any differences if you look at different languages instead of just Python? If you look at C or Perl.
Well, so all that's required for this measure, it's for this approach, it has this like extremely simple and cheesy looking diagram. All you need is a way to measure quality and a way to measure importance that you think means something. So certainly, if you use strict, does it still work? We can measure Perl's quality in different ways. We can measure C. Actually, there's been a fair amount of work on C and Java on having actually valid measures of code quality. How those results might differ. So far, every time I've run an analysis, the sort of high usage or highly important but low quality seems to come in at about 20%. So my bet is that there's always going to be that dirty corner somewhere. The thing that we haven't done. We probably know that we haven't done the thing, and we're just like, So some of those things might not change, but I do think that it's important to do this kind of analysis in multiple ecosystems. There's a lot of different ways that we can run projects, and there's probably more than one right way. And so finding what those patterns are, finding good measures in multiple ecosystems is definitely an area of future work. And if the National Science Foundation agrees with me and hopefully with you, maybe more work of this kind will be forthcoming. But yeah, thanks. Yeah.
If you're a contributor who's subjected to a project that's using scaling along with recommendations to put forward to fix problems, what can you do to affect change?
So you're sorry if I just repeat you're a contributor in a project that's struggling in some way, right? Yeah. So there's a number of ways that you can take action, and one might be to decide. First, I think we should always ask, should we walk away? If no one's using it and the quality's crappy and it used to be great and we all love the Atari and we're still trying to keep our Atari alive 20 years later, at some point, maybe you just want to walk away, or maybe you want to be the last person on your block with a working Atari. There's two ways to think of it, and both are totally valid. But if you feel like things are going toxic or struggling, you want to look at patterns of hierarchy and power and think about who besides me agrees that there's a problem. Let's think about how to change some of the rules. Let's think about how we can call people in and make changes. A face-to-face meeting or a face-to-face event, a developer summit or a retreat or whatever you want to call it, can really catalyze growth and change and improvement. So that's, I think, another avenue. Some communities only get better when they get forked. Sometimes they get better as a reaction to being forked, or sometimes all the good people will leave together and build something better. So that's also an avenue. I would say, too, that sometimes it just helps to have data rather than feelings. I love feelings, and I think those are important, but some people among us are unwilling to listen unless those feelings are backed with data. And so bringing more of the languages of power into that discussion can, I think, really improve things. I think it should be enough to say, hey, that makes me feel bad, but sometimes it actually helps to say, not only does it make me feel bad, research says you're killing our entire project. So what if you care about our project, you got to shut your mouth. Even if you have those feelings, you're going to have to keep them to yourself for the good of the project, even if you disagree with me about what feelings mean. I hope that's helpful.
I've got a quick question.
Yeah. Yeah,
Can
yeah.
you go to the chart with the quality over time?
Yeah. This fella?
Yeah.
So many wiggly
so,
lines.
So why are the quality lines so wiggly? Why is there such sudden shifts in quality over short periods of time?
So these particular measures are taken whenever a new release is uploaded or added. So in Debian, this looks like somebody fixed a problem, somebody uploaded a new version of the package. And some of these are sort of change more often than others because they're more actively maintained with new versions, essentially. So when the code changes, I run Pilot again.
Okay.
But it's at the distribution level, not at the Git level, if that makes sense.
Okay. So in one release, the quality can be at the very bottom, and then the next release, quality can be close to the top.
Yeah, people can put in really bad patches and changes and overarching things.
Okay, so that indeed can happen. There's just going to be very almost instant decline or increase in quality.
Yeah.
Okay.
Because of the number of changes or problems that come in. Somebody does a massive refactoring and they do it wrong. And also because I'm only comparing them to themselves, it could be that the variation is not huge. I mean, on here it's 0 to 1 because it's your best day versus your worst day.
Okay.
Right, so those extremes, this particular way of making things comparable means that those extremes are sort of enhanced or brought out.
So it has to do with how the data is presented.
I would say it has to do more with like this particular way of normalizing the data because it's a choice to make things comparable to one another. If I decided that the only acceptable, error per statement level was 5, and everything before that was bad and everything above that was good, then the data would look different. But instead, I'm just comparing a project's general run level to itself over time.
Oh, I follow. It's worst day to its best day.
It's worst day to its best day. Because I feel like that's a valid way to look at sort of within a community.
Okay,
yeah. I really have to let people go. I would love to talk to folks more about all of this work, though. Thank you so much.
Yeah, Corvallis Newport area.
Oh,
Yeah.
great. Oh, awesome. Middle of nowhere.
Where had Newport?
Hello, everybody, and welcome to SeaGL Day 1 of 2. I'm glad you guys have managed to stick around as long as you have so far. I hope everyone had a little bit of tea before you ran out of the hot water. That was a little disappointing. I am Bri Hatch. I would like to talk to you about how I make my life not suck with respect to getting my work done. These tools I'm going to talk about here today, Mosh and Tmux. And this is what literally saves my life and makes it so I can come in and out of what I'm doing at any given time. So what is the problem state? What am I trying to solve here? I work from a lot of devices. I got my laptop. I got a standing desk at home. I have literally my Android phone. I use these all over the place, right? I literally write code from my phone when my wife was like, come to bed. And I'm like, I am not sleepy. She's like, I don't care. I'm like, okay, I'll lay in bed and I'll sit there and I'll write code on my phone. She's like, it works great. This is an example of me writing this presentation a few weeks back from my phone. I also work from many places, and here's where things get a little more hairy. I work at, we do co-work once a week with our coworkers. So we all go to somebody else's house. We're on different Wi-Fi. I'm at a coffee shop. I'm doing an interview with somebody. I'm waiting for half an hour before they get there because I get there early. I'm in hotels where they got the nasty Wi-Fi that requires all this stupid jumping through hoops. I'm at conference Wi-Fi, which may or may not work at all. I'm in the airplane. All these things are kind of annoying. They're all a little bit different. Some are fast, some are slow, some are laggy, some are reliable. Not as many of them. But every time I would go between these devices, anytime I go between these environments, I have to SSH in from scratch, and I have to figure out what I was doing. I have to do some work, and then I come back to my laptop afterwards, and I'm like, oh yeah, my laptop was doing this. Oh, so now I'm in a different mode. And I go back to my desktop, and I can't do what I was doing on my laptop. Every time I switch a device, I have to recreate stuff from scratch. I have to close all my editors. I have to start over. And if I'm in a place that is like a bad network, then I might have it crash halfway through. And then I go, okay, well, log back in, make sure I know what I was working on, open up all my files, open up my code, try to recreate what was my state. And this drives me crazy. So like I said, constantly switching devices. Wherever I go, my connection might be bad, might be worse. Those context switches kill productivity. Constantly trying to remember where you were and getting back to that spot is a pain. If you got a computer with 55 screens, you want to be able to use them all. So the two tools that have saved my life. First one is Mosh. Mosh is effectively a replacement for SSH. We'll go over these in a little more detail in the next slides, but it is essentially just an SSH replacement. One of the cool things about it is you get persistence in a different way than you would normally. The other half of the equation is Tmux. Has anyone ever used Tmux? Has anyone ever used Screen, which came before Tmux? Screen was pretty damn cool in the day. Tmux, mucho better, much, much, much. It is the bee's knees. That's how I keep my state. You open up a Tmux session, and you can put as many little windows as you want in it, and then you can reconnect to it from a different computer, or from a different computer, or a different computer, or a different computer. You can just keep connecting back to that same thing, and all your windows are exactly where you were. And if you want to be a little more robust, you can add more windows inside there. You can split panes. We'll see how all that stuff works. But the most important thing, again, is I can get back to where I was. So details on Mosh. First and foremost, it is always encrypted. So you do not need to worry about security. It is not telnet. It actually literally starts with an SSH session. So you open up the Mosh command line on your computer, and you Mosh to username @host. Most of the same things you use for SSH are there command line wise. -l username or user @host. So you do Mosh instead of SSH. It connects over there. It literally starts with an SSH session. Then it does a little trickery. The Mosh server on the server side starts up a UDP port that is listening on 50,000, 50,001, 50,002, whatever. And now there's a UDP port. Who's familiar with TCP versus UDP? TCP is a connection-based protocol. It handles all things like waiting until a packet's been received before it's acknowledged. And there's a packet that says, yes, I got it. It's called an ACK. And so you go back and forth. Here's a packet. I got your packet. Thank you. I would like to send you another packet. I got that packet too. I sent a packet. I sent a packet. Hello? I sent a packet waiting for my ACK. Oh, I didn't get an ACK. I end up hanging up. TCP will eventually give up if it doesn't see a reliable connection. UDP has none of that goodness. If you throw a UDP packet, there is no way you're going to know if you got the answer there or not, unless you build some sort of protocol on top of it. And in fact, Mosh has built a protocol on top of it to recreate just the amount of reliability that is necessary to keep the packets flowing. If you've looked at HTTP in the new version called Quick, Q-U-I-C, the new version of HTTP actually runs over UDP and builds a bunch of those TCP features into it, so they can get reliability and can do pipelining and streaming, all sorts of really cool things when you have a connectionless protocol. So Mosh is UDP. That will be important for a couple of reasons. One, because we are expecting lag. We're expecting drops. We're not going to close the session because you suddenly lost some packets in a bad network connection. It also allows you to essentially move from IP address to IP address to IP address, and it will happily continue working. So normally with a TCP session, I'm coming from 1.2.3.4. If I'm suddenly on a conference room Wi-Fi on 2.3.5.7, it doesn't know who I am. The TCP session is no longer established. It doesn't even know what to do. It just drops your packets. Mosh has cryptography along the whole way. And so it knows when it sees a packet come to the port it's expecting it for, and the crypto still matches, that must still be Bri. I don't care if his IP address changed. I'll just let it keep working. So I can literally change IP addresses as I move around, which means the SSH session I have here running and one of the other terminals, I started 3 weeks ago. And I've gone to I don't know how many different places since it started. And it's just followed me along like a happy little puppy. The other big difference, that is on the wrong page. This belongs to the TMUX page. I'll get to that one. Okay, so what are some drawbacks of Mosh? It requires you have installed the Mosh client on your client and on the server. It's just an app to install away on or all the various things out there. There's even, as I mentioned, application for your phone. If you want to use it, I use Juice SSH. There are plenty of them. It doesn't do everything that SSH does. SSH has cool things like port forwarding, and agent forwarding, X11 forwarding. It doesn't do those. It is purely a buffer-based protocol here. So you don't get the real SSH components. It's also possible you might not be able to get all your emojis. That's okay. If you have to rely on emojis, maybe it's not the best use of your time. Because it's UDP and because it doesn't ever hang up on you, it also could mean that if you've legitimately closed your client, the server might not know if you closed it in a rude way. And so it might keep some server processes around, and you might never know about it. So you can get this little, you have a detached Mosh session on the server running message and it says, here's the PID, go ahead and kill it. Let me go back to this page here that I forgot to talk about because I was having a little brain fart. Mosh uses frame buffers instead of streams. If you are using SSH, and let's say you say cat enormous file, it will start shooting literally the 5 gigs worth of contents down to you. And let's say, who has ever done that and they're on a really slow laggy network and they hit Control-C as fast as they can, and there's mashing on the Control-C, and it doesn't matter because the server, you told it to cat the file. By God, it's giving you the file. And so you don't have a choice. It's going to wait until it gets to the end because it's already sent most of it to the kernel, and the kernel's job is buffered out to you. Mosh is not actually sending all the contents of a stream. It's giving you just a frame buffer. So if you got an 80 by 24 screen, it's using frame buffer to say, here's what's on coordinates 1, 2. Here's what's 1, 3, 1, 4, 1, 5. So it's essentially giving you screen refresh commands, which means that if you accidentally cat the file, it can't possibly keep up. But when you hit Control-C, it's going to tell the server Control-C, and it's say, well, at this point in time, what is on the screen? Cool. 25 gigs never came down to you. So that's kind of neat. That's pretty awesome. It also means that it might not be 100% accurate because, if things are going fast, things are going in flight, you don't necessarily want to wait and see if the text comes back. So it actually does a little bit of trickery as you're typing, say. It will use predictive text to say, okay, looks like he's typing ls, blah, 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 blah. And so as it puts it there, it actually preemptively says, I'm imagining these letters are going on your screen. And so it'll start showing the stuff you're typing, but it puts a little underscore as it goes, so you know, like subconsciously, this may or may not actually show up for me. But that means when things are laggy and you keep typing, you're sitting in VI, whatever, you still see what you're typing. And then the network comes back and it's boom, it's still accurate, you're all good. Bob's your uncle. It is also smart for those people who are enlightened and use VI. If you hit escape, it turns that off. Because if you hit escape, all bets are off. You're no longer typing stuff, you're issuing commands. So it's smart for those folks who are not Emacs people. No comment.
But there's only the editor of joy.
There is the joke. Okay, so if you're thinking, wow, all this stuff's kind of cool, well, there are also some limitations. If you're a frame buffer, then you might be saying, well, what has my scroll back? There isn't any. And that's one of the other two things that tmux is going to help with. Tmux, when you connect in, is going to be the first command you type, is run me a tmux session. It's going to take over your terminal and give you a brand new one. In fact, if you look over here, this is one running tmux. You look in the very bottom corner, you see SeaGL in the corner, you see the current time and date. This is me running VM into tmux. You make a new terminal and you get one window inside it. And then you can make multiple windows inside it if you want. And you can make multiple panes inside each window. So you can do things horizontal, vertical, cut them up if you want to. But the most important thing is you can disconnect and reconnect. So I mosh into the machine and I connect to the tmux that I was running yesterday, before I left the house. Instantly you're back at the same state you had. All your windows are laid out the way they were. You're on the same one you were when you started. So you can split things around. You can use mouse or you can use keyboards for all sorts of commands. As you're running things, you use the control B prefix command. So control B something tells tmux to do something, or you can run the same exact command with tmux space command. For those people in screen days, this is where tmux really shines. Everything you could do with a keyboard, like with control B, now also can be done with tmux space command name. We'll see a couple examples. Also, if you're thinking, but VI and less and all those things you control B, don't worry. We can make it feel more like screen and control A. So this is what you do if you're a Vim user and control B is your bag. You want to remap it, and control A just is the most logical default because that's what screen used back in the day. So this will make it so your control character is control A. I will, for all examples hereafter, use control A. So let's look at an example. This is kind of my screen. I've logged in, connecting with Mosh. We don't have to talk about Mosh anymore. We're just talking about tmux. I do a little grep. It's showing some things. I got the little status bar at the bottom. If we work from our left to our right, the first thing in bracket 0, that's the name of the tmux session. You can actually have multiple. I might have a scratch one and a work one and a home one. Then the next thing you see is 0 DNS and a 1 Pulumi. So that's window number 0, window number 1. I have completely different windows for that. And then we have more stuff on the right. It's a time and date. You can go and make changes to that. Here's an example of what I typically like. I turn off that leftmost part that said which tmux it is. So status left gets nothing. I set the status right to the time and date in a little better format, and I do both the local time and UTC, which helps if I'm looking at server logs. So I try to make it a little bit more compact, show fewer things. But the important thing is I can say tmux set blah, blah, blah on the command line, and it will make a change in the window I'm in. Or I could have done control A, set -G status left. Either of them work, whatever you think is best. And if you think that these are things you want permanently, then you can stick them in your tilde.tmux.conf file. So this is really convenient. You can make commands that are running tmux sessions. You can run aliases, whatever you need. So let's do a concrete example of something you might do. I want to run a whole bunch of things in parallel. And I want to have them literally run in parallel, and I don't even want to see them on my screen. I want to see them all independently. There's no real easy way to do that other than spinning up 25x terms or whatever. But if you're in tmux, let's say we say, I want to get a whole bunch of hosts, and on each one of those hosts, I have a whole bunch of containers that I want to update. I'm going to tmux new window. I'm going to make a new window inside my existing tmux session. I'm going to SSH out to that machine. I'm going to run a Docker pull on it. I want to do all these things in parallel without writing any real code. And once I hit enter, my for loops inside for loops, boom, run all these things in parallel. I've now done control A W, which shows me the windows that exist. And now I can go up and down. See the little yellow line is the current window that I'm highlighting. If I hit enter, I'll go to that one. These are all the things that have started. In actuality, they go much, much, much further. I've, let's say, 5,000 hosts. Running these things literally all in parallel. Each one has started up its own window. If you look at the bottom, we now see ProdWeb 0, foo, Nginx, ProdWeb 2, ProdWeb 3, ProdWeb 4. So I've now got a whole bunch of separate windows, and in the bottom half of this screen, I can see a preview of what that window's doing. So if I'm waiting for them to all come complete, I could literally just sit here and watch them slowly filter as all the Docker ups are completed. And I can look at the ones that are taking longer, and I can go and investigate them one by one. So tmux, really, really powerful. So let's talk about some tmux commands. Tmux list sessions. Again, you can have like the home session and the work session. Try not to cross the streams. If you don't give a specific session name, it'll just pick the first one, call it 0. That's fine. You want to make a new session, you can make a new session. You can give it a name if you wanted to with -t. When you attach to one, you can attach with a specific session if you want to. You can also detach anybody who is currently attached. So let's say I'm on this laptop, and I want to go over to this laptop over here. I could go over to this one and detach the session from this one, so they're not both running at the same time. Or I can leave them both running at the same time, which is kind of cool. If I want to detach, obviously I can close my window, my terminal font, but I can do it, tmux detach or Control-A-D to be convenient and friendly. So let's say I got a bunch of windows going. I want to be able to go back and forth between them. I'm writing code in number 0, and I'm doing deploy in number 1, blah, blah, blah. Making new windows, Control-A-C, and all of these, by the way, have tmux equivalents. So these are the ones I typically use as the command, or the control versions. Control-A-T will open up, or C will make a new window for me. It will start at 0, 1, 2, 3, 4. If I want to navigate between them, you can Control-A0, Control-A1, Control-A2, all the way up to 9 to get through the first 9 of them. If it's beyond that, you can't do it with a single letter. You can't do Control-A. Don't think like you're in hex. I see what you're doing. Control-A-N will just move to the next window. Control-A single tick will let you select a window. So I can say Control-A tick space 10. That will move me to number 10, if I happen to remember 10 is the one I want. But as I showed a couple pages earlier, Control-A-W will give you a list of windows. And you can just literally up and down arrow. And you can see a preview and decide what you want to go to. So that's also a convenient, easy way. If you want to do scroll back, remember Mosh is a frame buffer. Mosh doesn't do scroll back. The scroll back is built into tmux. So Control-A bracket. I know, it feels weird. You get muscle memory, don't worry about it. And then you can, Control-B, Control-F to go backward and forward and see stuff. And you can also have copy and paste from there. If you want to rename the window, Control-A comma and give it a thing. So SeaGL rocks, or tmux rename window from the command line. If you want to close a window, if you want to close a pane, if you're in a terminal, just type exit is the easiest way. You can also, I think, Control-A-K for kill, but I could be wrong on that one. So panes, how do I have multiple shell sessions inside a single window? I want to make my stuff smaller and smaller and smaller, more dense and more dense. Control-A % will split it horizontally. Control-A double quote will split it vertically. Control-A colon resize pane space minus LRDU will let you resize them bigger or smaller, left, right, down, and up for whatever pane you're in. You can turn on mouse mode, which I'll show you in a minute, is actually the easier, lazier way of doing that. If you want to go between the different panes that are there, Control-A-O will rotate through, or you can do Control-A up, down, left, right to move between the panes that are on the screen. It feels more natural than it sounds as I'm standing up here. Don't worry. So let's do it. Okay, I'm in Vim. How many windows do I have right now? 1. What's it called? How do we know that? It's down here in the corner. How do I make a new one? Anyone remember? Control-A-C. Now I'm in a new window. This one's called Bat. Oh, Jesus. Come back. Be on Etsy group. And I'm like, oh, yeah, I would actually really like to see the password file while I'm here. Control-A %, and now I've split it in half. Less Etsy password, which is the user I'm working on. Oh, yeah, nobody is looking at it. So now I can instantly just go back and forth between these two things. And if you are in mouse mode, then I can move my cursor, if you will, between the two by literally just clicking. So now it's over here on the top on root. Now it's over here on the right on SeaGL. I can also do Control-A-O to go back and forth if you're feeling just keyboarding. And if I want to resize it, I just drag that. Okay, cool. But I want even more dense than that. Let's, what was the other one? I forgot the vertical split. Double quote, yeah, I accidentally type that all the time. So now I got 3 of them. So you can see, here's the green line, tells you kind of where you are. And so I'm moving around. So let's remember, we're not supposed to just talk about that. We're talking about Mosh. So let's turn off our Wi-Fi. Ah, that's the right sound. Okay, if I type, Nothing's happening. And look, there's this big blue bar saying the network is not working. That's okay. The network's not working. The network's not coming back. But you know what? I got a hotspot on my phone. Let's connect to my hotspot. Where'd the Wi-Fi icon go? Give me a moment to connect to Mosh TMUX as opposed to University of Washington. And oh my God, I'm back where I was a moment ago. So my IP address changed. I should have shown it before and after, but trust me, I went from the University of Washington to my Bry high spot, and boom, my session's still there. Doesn't matter where I am, it's still there. It's like a happy little puppy. So that is the fun part there. There's nothing that says that I can't attach for multiple things at once. For those who are at home, you can't see. I'm typing on my phone into the TMUX and Mosh that is running on my laptop. So now I'm on both. And if you're wondering why suddenly I got all these dots on the side, it's because the screen of my phone is really, really small. It's much harder to see. So it doesn't want to make it wants to make sure everybody can see the same stuff. Now, if I Control A D on my phone, I've disconnected, and now it goes back full screen on my laptop. So everything is available. Everything is persistent until my computer on the remote end turns off. Never reboot your computers, people. It's just not a good idea. I did not say that. From a security perspective, that is the wrong answer. Don't take my advice. Everything is persistent. Everything is available. Everything is going to survive nasty networks with unreliable packets. It makes my life the bee's knees. Questions?
Can you do like commits?
Can I do what?
Can you do like a commit session that you need to be able to do if you might have 2 different people?
If you want to have 2 people who are both connecting to it, you do need to have write access to the TMUX socket. And you will need to run TMUX with the flag saying, here is the location of Bry's TMUX socket because you're logging in mine. And then, yeah, you can. And then you can do everything as me. So I better really know who you are and trust you. But if I give you, Unix permissions to it, yep.
In one of the great demos I saw from the gentleman that wrote Spec, he actually made a program called for bits.
Kibits, mm-hmm. Yep. So you could make it like if you're doing a screen share and I can't give somebody control of my computer, I could, via Zoom or whatever, I could literally just have them SSH to the same machine and connect to my TMUX session. They work together. Question over there.
If you've got TMUX and like Resurrect or something going, like why do you need Mosh at all?
You don't need Mosh. TMUX can be great for running along live command and running away from it and knowing it's going to continue on. Mosh for me is mostly useful when I'm going between devices and I want to connect back to that, or if I want to have my stuff on this computer here and I've got a nasty hotel Wi-Fi. Sometimes I do TMUX, or I do Mosh, and it still works on the airplane, even though I'm not paying for Wi-Fi, because UDP gets through for free. So sometimes that's a value. I think I have time for one more question because we have people after this.
Where's your Mosh server running right now on your laptop?
No, the Mosh server runs on the machine I'm connecting to. So in this case, it's a Linode that I built specifically for this talk. But if it's something in your office behind, say, VPN or whatever, that's still fine.
Okay, so that's where the frame buffer is.
Correct.
So that's really what you don't want to reboot. You want to retain.
You should reboot your computer periodically. Don't listen to him and me.
But I mean, your frame buffer data right there.
It's coming from the server. Yep.
And it is in encrypted state.
And it is, well, it's running inside the Mosh server. And the Mosh server has stuff in clear because it needs to be able to think it. But when it goes across the network, it's entirely encrypted. Okay, one last one.
Is Mosh still seeing active maintenance?
Yes. Is that a good answer? Mosh is still seeing active maintenance. Thank you so much.
off topic, but never programmed. I've never actually programmed anything on my phone myself. How do you? I have played with various things, but how do you get escape keys and funny things like that going on your cell phone? That's convenient. And can I do it online? Or Android? Yeah. Especially, I don't want to adapt your key crap. That's well, like swipe to text is not going to work. Obviously, that doesn't work. Let's go outside. So sure. Yeah. Thanks. Nice talking to you.
All these are required. So
Yeah.
we need to be in room.
All right. Hello and welcome to Hands-on Tensegrity Lab. I did promise you a little bit of education before we start building. So, tensegrity is the characteristic property of a stable, three-dimensional structure that consisting of members under tension that are contiguous and members under compression that are not. It displays an equilibrium of forces as demonstrated mathematically. No, we're not doing that. We're looking at these things. This is probably what you think when you hear the term tensegrity. And you think of these sculptures that kind of seem to defy gravity. You're like, how does that even stand up? Well, another thing you might be thinking about when you hear about tensegrity is there are people who are like, a cell has like the cytoskeleton and it's all tensegrity on the inside. Now, cells definitely do have a cytoskeleton. Whether it's actually tensegrity inside, I am not enough of an expert to tell you. We're going to be talking about and building the architectural version today. So there are basically 6 principles of tensegrity that I'm going to run you through super quick. So we're going to talk about tension, compression, stresses, equilibration, minimalism, and scalability. So I am throwing a few engineering terms at you. The ones that you need to know are compression. So if I have a beam like in the ceiling up there, and we put weight on the beam, then the top of it is going to be in compression and the bottom of it is kind of going to be in tension, because tension is when you're pulling on something. Like a rubber band here, an elastic band, is going to exert tension on the things on both ends of it. We also have shear forces where things try to slide past each other. We also have torsion forces where things will try to twist. So with those words defined, conventional architecture is going to have all these forces, but it's going to have solid beams dealing with our tension and our compression. Parts of each beam are going to be under tension, parts of each beam are going to be under compression. And that's the building we're currently in, that's probably the building you live in, that's most buildings. However, we can decouple the tension from the compression and get these tensegrity structures. So first principle of tensegrity, continuous tension. Whatever our tension members are, I'm going to call them cables throughout, although they're probably going to be rubber bands when you build yours, are always going to be a little bit stretched. If you've got a rubber band that's super duper loose, something has probably gone wrong. Another point is discontinuous compression. So we're going to build compression members out of various things. We can use popsicle sticks, we can use drinking straws, all kinds of common household objects. But the things that are taking our compression are going to sit separate from each other in space. If we find them resting against each other, something has probably gone wrong. We've also got the element of being pre-stressed. So our buildings are going to start with a little bit of tension all through them. There's going to be some compression even when the whole thing's at rest. And that kind of creates this equilibrium within the sculpture or the building that you're creating, which ties into our next principle of self-equilibration. Equilibration, difficult word, relatively simple concept that if it needs to kind of adjust itself a little bit, it's able to do that. There's a little bit of motion there in the structure. Second to last principle, minimalism. We want to use pretty much as few materials as we can to get the job done. Now, we're going to violate this principle just a little bit when we use rubber bands, because the easiest way to use a rubber band between point A and point B is to double it up, to have 2 of the same rubber band. If seeing it twice bothers you, you can put a little twist in it as you're putting it on, and then it'll look like one thing. It acts like one thing. It's the minimum that we can build really conveniently with household objects. If we were going for single cables, you'd have to be tying a bunch of knots in string, and that's just hard compared to sticking a rubber band on stuff. And the final principle is scalability and modularity. We're going to build a first little simplex 3 prism, and you're going to be like, what even is this? This is so boring. And then we'll stick them together and make towers as big as you want to. So anytime you look at a piece of tensegrity art, you're going to see it's this repetition of the same module over and over very often. So looking at these with what we know about the principles, that we have continuous tension, discontinuous compression, we could start making an argument that the really famous floating table doesn't quite satisfy those particular principles, because it's got this joint between the compression members that are kind of taking some tension in that joint to keep it from breaking. where it intersects at that right angle. So what tensegrity really is depends on who you ask. Who should you ask? When did it even start? Well, the first recorded instance of things that look like tensegrities being documented is actually from 1921. We don't hear a ton more about it until the 40s, when Kenneth Snelson starts building these art sculptures and calling it floating compression. That's him with one of his sculptures, not sure when the photo's from. And then, so he's a student of Buckminster Fuller, and Buckminster Fuller puts the really catchy name tensegrity on it and popularizes the concept. There are also ways in which a lot of traditional things, like traditional ways of building kayaks, for instance, demonstrate a lot of tensegrity principles, but we weren't calling it that back then, so Fuller takes a lot of the credit, for better or worse. We get this cool buzzword that got you all into this talk to try to build some. So with that, let's discuss how we're going to build these. There are a few dangers of building stuff, because there's dangers anytime you build stuff. We've got some tools, we've got pliers and scissors. These cut things, these pinch things, that's their job. If the thing is you, it will hurt. We are using wood. If you manage to break the wood, it will have splinters. If you're unbending paper clips to play with, they will have sharp ends. Rubber bands can go everywhere. Amazon claimed that these are latex-free. Trust them as much as you trust Amazon. If you have latex sensitivities, be a little cautious. But with the appropriate caution around our household objects, let's look at how we make our tensegrity members. So we've got many things to build struts out of, many things to build cables out of. When you're choosing your struts and your cables, there are some considerations to keep in mind. Basically, you're going to choose your strut size based on your cable size. And when you're looking at an assortment of elastic bands, deciding which ones you want as your cables, what I like to do is put a bunch of them on your hand, untangle them, and see which ones are the same length. Now, we've only got 2 lengths of rubber bands in this kit because I wanted to make it easy for you. But if you get a multi-pack from somewhere, there's going to be a bunch of different sizes. Within a single sculpture, if you want it to come out symmetrical, you want to use as close to matching rubber bands as you can. So I'd use either all these ones together or all these ones together, because they're basically matching groups. And then the simplest strut that we can build, that's going to be the easiest to build with, is going to be just any 2 popsicle sticks. And what we're going to do is we're going to stack them on top of each other, and we're going to offset them just a little bit, like a millimeter, so they're not quite perfectly lined up on those short ends. And that's going to make it easier for us to slip the rubber band in between them once we've taped them, because it's almost like a little pincher that's going to grasp that rubber band and hold onto it and help us keep the sculpture from falling apart. So once we've got our pair of sticks, we've got them offset just a little, we're going to take a couple pieces of tape and we're going to tape it a little ways in from the ends. Now, how far in from the ends? Well, the size of the rubber band probably wants to go about like that. Like the end of the tape, making that little open end of it, should be about the length of the rubber band, more or less. If it's way further, way less far, it's going to be harder to build. So that's about how we're going to assemble those. There are many ways you can do struts. We've got some toothpicks and teeny tiny rubber bands if you want to build a little bitty tensegrity. We've got some skewers if you'd like to use some big rubber bands and build a bigger one. If you're using drinking straws, do them top and tails so that they reinforce each other on the bendy part. And if you're using skewers, mismatch them a little so the pokey part isn't the thing that sticks out the furthest, and then you'll be less likely to get poked by your tensegrity structure. And then when we're connecting with these struts that we make out of 2 pieces, we will just pull the rubber band into that gap. And you might think, oh, if I tape them together really close, the rubber band won't go in there. Well, actually it will, because you stretch the rubber band, and it gets smaller as it stretches because physics is cool like that. So another way that we can make some really pretty, really lightweight ones is we can use our bubble tea straws, and we can use a hole punch and just make holes near the ends, do a single scissor cut into each end so that you can just pop the rubber bands into the holes, and that's also a perfectly valid tensegrity strut. So however you want to build your sculpture, you can go for it. So I'm going to teach you the really simple one, and then give you a minute to come get some supplies, try building those, and then I'll bring everything back together at about 1/2 past, and teach you a more complex one that takes a couple more struts once you've built some out. So the way we're going to build our simplex structure is we're going to make 3 of our little struts by taping them with whatever kind of tape. Type of tape doesn't really matter. I often use electrical tape so you can see it, but you're just going to cut yourself a couple pieces of tape and do that. Just tape around them so they're a pair and make 3 of them. And then once you have your 3 of them, it may help to number them 1, 2, and 3, because once you have your 3 of them, you're going to clip all of the tops onto one rubber band. You're going to try and get them at about thirds of the rubber band, but if they're not perfectly thirds, that's fine. It'll be easy to fix later. And you're going to clip all the bottoms into one rubber band. So you end up with this kind of weird cylinder. So instead of 1, 2, and 3, I'm going to do yellow, red, and orange, because those are the sticks I grabbed when I was setting up. So they don't have to be like perfectly identical, but the closer to matched up you get them, the nicer and more symmetrical your final product will be. So one more strut, and then we'll be able to put them onto the top and bottom rubber bands. And then once we've got the top and bottom on, there's a couple different ways we can think about the next step. We're going to be connecting tops of the tops of each stick goes to the bottom of a different stick. Now, if you like numbering everything and naming everything, then you're going to say the top of stick 1 goes to the bottom of stick 2, the top of stick 2 goes to the bottom of stick 3, the top of stick 3 goes to the bottom of stick 1. Or if you don't like naming and numbering everything, then there's another way that I'll show you as well. So I've got 3 struts here. And first, all of the tops. So when you're putting the rubber band on, you can kind of pull it against the longer side because you've offset them to stretch it out, and then pull it downward. Just hold on tight to the rubber band and to the sticks as you're pulling it. And then we get one end on, and they're just kind of stuck together. They're not really going anywhere. That means it's doing what we want it to. And then we're going to put one on the other end as well. Now, if you're just scrounging rubber bands from around your house for this, you only really care that the top and bottom 2 match, and then the 3 vertical ones match. So we're making a little cylinder, so that's going to come in here. And there are very few ways to combine this. There's, I think, only one wrong way to do this, so if you do it wrong, you'll know and you'll fix it, because they're very easy to put on and take off. So we've got our little cylinder thingy. So we're just going to assign them 1, 2, and 3. Doesn't matter. Let's do it red, orange, and yellow. So we're going to go from the top of the first to the bottom of the second. So top of red to the bottom of orange. And then we're going to go from the top of the second, which is going to be orange, to the bottom of the third, which is going to be yellow. And then there's only one remaining pair that only have a single rubber band. And then on the other side, we've got this top of yellow to the bottom of red. Those are lonely, so let's give them a rubber band too. And suddenly, modulo getting the tensions right, we have, oh, I needed to flip that around. And if you ever need to flip something around, you can just take it off and try again. Look, I was talking while building and got myself confused, so I can just pull them off, and then, let's see here. The other way I like to do it, so numbering them really doesn't come naturally to me. The way I like to think about it is that I like to think about it as 2 of them cross, and then the other one's just kind of floating around here, and it's like an arrow that hit that target. So we've got like our X, Y, and Z axes. And then how do I know which ends to go together? Well, I can't do orange to orange. We're not going to connect the same stick to itself. And when we're doing the little X, Y, Z axis way to make the exact same thing, then we don't want to skip over one. So I don't want to connect orange to red, skipping over yellow here. I don't want to leave yellow out like that. So when I've got it held this way, if I follow those 2 rules, the only connection I can make is this end of the orange to this end of the yellow. So I think one way of visualizing it will probably make more sense to you, and the other way will probably be like, what on earth are you talking about? But then, so there's the first one, there's the second one also happening on the outside of the structure, and I'm guessing from the rubber band lengths that these green rubber bands I'm using may be a little too long to make it really have nice tension. And if the rubber bands are too long, you get to, especially with popsicle sticks, yep, look, it's way too loose. It's the right shape, but it's way too loose. So I can shorten the rubber bands up by wrapping them around a couple times around one of the sticks, and that just takes up some of the length from it and makes it basically fully customizable how you want your sculpture to act. And so once you make one of these, you're like, oh, that was pretty easy. I've found a size that really works well for the materials that I'm using here. Then you can make another and just stack them together into a prism that basically gets as tall as you want it to. Let's see, so I want my triangles on the top and bottom to be kind of even. This one's really short and this one's really long. Oh no, how could I possibly solve it? I'm gonna pull on the short one to match up with the long one. So modulo a little bit of tightening and tensioning and getting it just so, we get this nice freestanding little simplex module. So this seems like a good time to let everybody come up, help yourselves to materials, and start building a few little modules. I hope that's not applause worthy. I hope that they turn out very easy, but we can make quite a stack of them.
I think I'm going to make anything one so that it's easy to.
We do have a couple tables over there if you'd like to work on a table. You can also work on a chair. Oh yes, absolutely. Let's find a hole punch in the tool supply. Yeah, the hole punch method works with thick straws. Yes. All right, and we have several hole punches.
Oh, that's right. Yeah, so that's the one.
What do you need, a hole punch, some rubber bands? I just happen to have an easy reach to it. Scissors. So when we're hole punching, I'll just do a really quick demo of hole punch. So when we're punching holes, we're going to stick the whole straw in there and punch through both sides like this. So however far in you do it, you just make them all basically the same. You could do it way far in, you could do it further out, but you're probably going to want to start by looking at the rubber bands you're using. So you need 3 sets of
when you're doing the hole punching, you need to squeeze at the end, otherwise you don't have enough leverage.
Yeah, so one thing that I like to do when a tool is too strong for me, I like to put it on the table and then push down with my whole weight. Nice. There you go. Yeah. Those are hole punches because you can do it with any material.
We need one on each side.
Yeah. Oh, I didn't see you. I thought you wanted to. Okay.
You can just take the whole tape to spin.
Okay, why don't we just take one then? Just leave that one here. We'll keep this one.
We have enough tape that we can spread it out through the room. I'll put some tape and scissors here on this chair for people to use tape and scissors. How can I
Sorry, I shouldn't
fix
be.
this assembly line?
You need a set of 3 and a set of 2.
All right, so you can just grab a big handful and take it with you and then put the extra
Guys, this is hard.
The hole punching?
Yeah.
So we have
Or here.
smaller ones, and then
You want to do some taping while I do
skewers
it?
may be advantageous with a bigger band. So it's like, I'm not going to use the bands are big enough. So skewers will behave themselves better with the big rubber
I don't want the
bands.
tape to be too close to the end. Just enough.
Yep, there's really a lot of room for error in here.
Okay.
Okay.
Want me to do the
Could I actually ask you to step back so I can fold up this? Could I ask you to step back real quick so I can fold this table into another work surface? There we go. And then can I ask you to work down here so that other people can easily get to the materials?
You are able to make that request.
He needed a set of 3 instead of 2. I've got 2 shorts and 3
Yeah.
longs.
So when we are choosing our
Hello.
when we're choosing our rubber band size relative to our holes, we kind of want it to be about as far apart as the rubber band is long when it's
Probably
relaxed.
gonna want
Yeah.
See?
So actually, I bet the shorts work for you because we don't want it to be too long.
I'm gonna
So
take your word for
it's
it.
going to be, yeah. Yeah, the shorts I think will behave better for you.
Stretched a little. All right.
Because we do want that continuous tension to be happening.
Okay, I'll swap these out.
Yeah. We've got a variety of scissors in here, although we've got some scissors on the chair too, behind you, green ones on the chair behind you. And this is the day of vindication for people who carry a multi-tool. Yeah, you're going to want to snip that down. Perfect.
All right, squeeze.
Making noise, that's where I am.
That's okay. Just grab a whole handful and put the excess back when you're done.
Put this in here and there we go. All right, we'll get to it in a moment.
I'm using the big straws.
You're using the big
So
straws.
I can see.
Okay, I'm done with that now. Your big straws are ready. The big straws are all hole punched. So I can get into this.
Yeah. So now I just.
Thank you. You are making good progress.
Like
No like
this.
your work was good.
So I just cut these.
Oh yeah, absolutely.
Yep. I think that's right. So that you can get the.
So we're going to have 2 matchy rubber bands and 3 matchy rubber bands. Then 3 struts for the simplex. And
Yes, that makes sense. That really makes sense to me.
smaller bands
I think you follow the
the
instructions.
bigger bands on double straws. Don't have to be the same color or the same size.
Figure out how to make the thing that's most likely to get confiscated by the
Well, the nice thing is you can make another one when you get home.
I know. 5.
Well, if we have computers at home.
You can get something. These are household common materials.
Yep. So, do you think you can find something at home that's straight and resists compression? I can think of a few things that I have at home that are like that.
Well, at home in my house.
She means you can wait until you get home. It's not just the place we're staying.
So you're cutting
Yeah,
on
so-
both sides. Up to the hole.
So that we can just.
I want
So that we'll just be able to slot them in. It's like a self-threading needle if you've ever sewed with one of those, which you might not have. So this way, when we get ourselves some rubber bands.
Now,
You'll need probably 5, and the long ones may not behave as well. So,
one cut on a section.
the basic idea that we're doing here with the straws is
Put the bottom on, go up to its top.
Find out.
Next one.
Now, if you are using the bubble tea straws, you will have one extra step on the top and bottom ones. You'll need to give it a little wrap around so it doesn't slide back and forth too easily on the rubber band, because we've got one rubber band pretending to be 3 of them. So I'll just put a demo out with this so that everyone can.
That's correct.
There we go. That should. We'll be fine. It'll look silly and be a demonstration of why we use large rubber bands sometimes. Like, really trial and error to figure out how to get it how you want it is kind of the name of the game. So yeah, just cutting into the hole so that you're able to slip a rubber band into it. Because then it just kind of holds on to it for you. There we go. So it's kind of like that.
Yeah, I feel like I'm gonna want a longer band.
Yeah, the top and bottom may want to be long ones.
These are the same yellow ones, but
Yup, yup. Wrapping them around is a bad idea. Yeah, I think I misled you there. Yep.
No, you want to connect to the tops of all three.
Is you're recommending using a longer?
So basically, you put it together and you see if you like it, and if you don't like it, I'm like, oh, it's technically works, but it's kind of sad.
Oh, because it's so tight?
Yeah, I think it would be happier with a longer top and bottom one.
Cylinder. Double up.
Just cutting them on one side?
If you cut it on both sides, then you're able to kind of attach the rubber band like this.
Both sides better?
Yeah, because I think if you only cut it on one side, the rubber band might not go all the way into the hole for you.
Okay, top and bottom, both sides?
Yep.
It should be in thirds though. You want the length between all of the sections.
Yep. And your thirds don't have to be perfect at first, because you can always change it later. That's the nice thing about the Legos of construction projects.
It doesn't have to be perfect, you want it to be like a triangle.
There we go. This will probably behave itself better, because then we go. One.
Go and check on this way. Come back and play with that. The fact that it's just like, oh yeah, we're combining this and stuff.
Sometimes I just end up with my hand completely stuck in a sculpture while it's half finished. Yeah. There we go. There we go. That's a better demo of what we're looking for. And then, oh no, my triangles are all messed up. I'll just pull on the ones that are too short and fix them. So this is what you'll end up looking like with the bubble straws. So if you are struggling with the bubble tea straws and you'd like to see an example, it can help, it turns out, with these straws to use one of the really big rubber bands top and bottom, and then the shorter rubber bands for the verticals. So if your triangles aren't triangular, that's really easy to fix. You just kind of pull on the side that's too short, so it takes up some stretch from the side that's too long.
Look at this. It's obviously wrong.
You're getting there? Let's see what happens.
Here's
So,
two sentences,
first the second.
30 lines of text. It's just like I
think the tension for the struggle here. I think if you use wrapping it around to take up the stretch in these steel bands and get them tight enough, I think it'll come into the right shape.
Okay, that's what, thank you.
I'm trying not wrap. No, that's fine.
Yeah.
I was just like having trouble.
Okay.
So the fact that
Yeah, that's fine.
But it's structurally
just like shit out.
Yeah.
it's got the spirit.
That's hard enough. Yeah. And then if you make another of it, you can just start
Well, my whole thing is it's like
patching it on there.
Huh. Oh, there.
Hey, that looks
And
like
if you
something.
swap out some of the top and bottom rubber bands for bigger ones, and then you take up a bit more tension out of your side ones, then it'll get kind of a flatter look.
so phenomenal.
I think those might be longer than it would behave well with the struts. The bands are much longer than the struts there. So we do have short bands. Yellows are all short, teals are all short. So, and with these popsicle sticks, it often helps to just do an extra wrap around the stick.
Fiddly.
They are. And the first few ones that you do are just like, what on earth is even going on here? And then you get used to it and you're just like, oh, that's what's going on. Let's see here. So if we want it to sit like this, yeah? So we think, let's hold it how we want it to sit. And then where is it too loose when we hold it like this? Yeah, so one of them is just sort of sagging, right? So we take the one that's sagging, and where is it really tight on that same one? So can we move some tension from the one that has not enough rubber band to the one that has too much rubber band? So where it's really tight, it doesn't have enough. And where it's really loose, it has too much. So can we pull on the one that's
underneath, they're underneath each
so
other. So
can we just pull hard on there? No, you don't have to take it out. You can just pull through. There you go. And look at that.
Look at that. Perfectly unified. Thank you.
You're welcome. So if you have a sculpture that you're troubleshooting, one way that you can approach it is you can hold the struts how they should be and look at where is there too much tension, where is there too little tension. If something is too tight when it's in the right position, can you make that looser? If something is too loose when it's in the right position, can you make that tighter? Okay, you do have them in the right configuration, but they are quite loose. So you can tighten them up with a little bit of an extra wrap to get the nice bouncy spring integrity.
Yeah, that extra wrap you can also glue.
Yeah.
Not worry about it.
Yeah, they will slide around without an extra wrap on the straws, but
Oh, well,
yep.
I'm not too
Yep. If you end up finding out you need it, then you can go back and add it. Come on, friend. You can do it. There we go. You're getting there, and just each time you just kind of think about, like, where is it too loose? How can I take out some tension?
Fell over. One more. Should I make one more?
Build more. Build more in the
Last one. More.
Gee, I don't know.
Oh, those are long ones. You gonna build a big one?
Literally, you got me
You got some smaller ones.
What's going on here?
the command.
So I started with like really thin
Just doing the big one.
Yeah.
It's like,
We make a big one? Big ones?
You might have an easier time to take that tape off your fingers, too. I've been recovering from surgery, so I'm super aware of how inconvenient it is to have a whole thing in a commission.
I like to think them as well. Should we try these ones?
I have an idea.
Okay, we'll try these then.
And it doesn't have to go underneath the other rubber band. You can put the purple one on before the green one if that's easier. Exactly. Yeah, now it's gonna kind of, it's gonna get to that equilibrium. Now, there's a then this purple one isn't between the two struts, so it's sliding down. Do we have continuous? Yeah, we have some continuous tension there. If you were to use the larger bands top and bottom and the smaller bands in between, you get a flatter look.
When I tried to do that. The smaller one
Okay. Another thing you can do is use some tape to hold them in place once you put them all in for an end. There's no rule against putting more tape on the ends if you want to pull hard on the bands. Yeah, use tools. Oh, don't stress about destroying the struts. They're for the dollar store. Ah, true.
I did it.
Hey, you did it.
I have to leave now.
Yeah. Awesome. High five.
Yes.
Yes.
Where are you on the internet?
QE Dunham on the Twitters, QE Dunham on the LinkedIn's.
Are you on the Fediverse?
Not really, but I ought to be.
I've heard that so many times today. Someone interpreted my email address as a Fediverse
little bit of a
address.
loop to get a little more tension in, and the structure starts to
Yeah, and then you start looking at triangles and you start asking,
Yeah.
are
Just
these
as a
equilateral?
web
What can I
finger
change to make them
alias to
equilateral?
my
This
actual
one
address.
is.
You could join GNU+Linux.social. I'm sending GNU+Linux.social.
Yeah, so you can just swap them.
In case it wasn't explicitly clear the kind of person I am.
One other thing we can do is we can tie a knot in a band and make it shorter. Yes, that is me. You don't know that. I'll put Fediverse on there someday, I hope. I've been really meaning to like get my entire life onto XMPP because I want my house to talk to me and I want to
I have Cheogram installed, and I walked over to the JMC people and I was like, thank you for being a thing I can give money to that is not
take a
Google.
look at this.
Yes.
Can you believe it? I'll just take a look.
Huh.
So, so I see the end to end, end to end. You've got the connections right, but then when we start looking at, let's hold them in the position we want them and see where is there too much tension? Where is it pulling really hard? And is there anywhere so how can we give it a bit more rubber band into here? What do you think?
I haven't separated
You might. Yep.
Even handle some external
So you have a tension in your structure.
So now, before we put that back on, just take another look at it. So do we have something that's too loose on this triangle? So, and we have one that's really tight and one that's really loose. How can we fix
Mine's already
that?
put to work.
How about we try pulling on the one that's too tight so it'll steal some from the one that's too loose?
Right.
Yeah, look at that. Look at that.
Wrap it around one
And then came a little unanchored, so we're just re-anchored here. Now, if it's feeling like these blue ones are too light, as soon as I hand this back to you, I'll grab a rubber band and I'll show you a trick. So, I'll show you a trick. So here's a rubber band that's way too long, and I only want it to be this long. So what I'm going to do is I'm going to tie a little knot in it.
Off center.
Do you want to try tying a knot in this rubber band? To get the feel for how you do it. You're going to use both sides at once, just like tying a knot in a piece of string. Kind of like a tie in your shoes. It's a little tricky, but I'm sure you can get it. Practice a little bit.
This triangle, this one is isosceles, not the equilateral.
That's okay, no, it's gonna work, it's gonna work. Good enough. Now it's short, now it's short. Now you can use it for this one. You're good, so go ahead and try it. If you want to adjust it pretty slowly. It's not just, right? Oh, and you want to knot these to make them shorter then? Oh, and you want to knot these to make them shorter?
I brought you a background. I just wanted to show it to you. They're not touching. They are touching.
Nice! Good work!
They don't.
So that's the end it wants. It's not useless. We can make it part of a tower.
I mean, you can stand up if we can do this. Oh, look. Oh,
And clip it together and make a tower from it if you want. But you can make it more symmetrical. So we want these teal ones to be triangles.
Yes. Oh,
So
okay.
we want them equilateral. So how can we pull on it to move some length from one that's too long to too short?
It really is funny what a different kind of physical
You're getting it.
approach.
Yes.
So there's one other trick that's been helping people as we've been troubleshooting up here at the table, which if you need any troubleshooting help, you're welcome to bring it up. The trick that's been helping people is you look at the ends of your tensegrity that should be equilateral triangles. So what are shown in orange on the diagram end up as equilateral triangles. And if one side is too short and the other sides are too long, you can grab it by the one that's too short and hold onto a strut and just pull on the one that's too short to steal a little bit of rubber band from the side that's too long of that triangle. So you can just adjust it a bit once you get it together, so it doesn't have to be perfect when you first put it together.
Much easier. More space. Boink. Stay.
High five. Amazing. Oh, I know you've made two overachievers.
Okay.
Incredible.
Someone else made that.
Since we have two, let's figure out how to make a tower from.
Right. I think their bases need to be a little bit more aligned.
I'm not so sure about that. I think we can make a whiskey tower.
Ooh, I love this.
I think it doesn't care too much if it's a little bit asymmetrical. So what we're going to do when we're making a tower,
Put the bases on the tension lines there, so
those
that
bases are going on there.
Connect the bottoms to this.
Go on.
Oh, to
So
make
that
a
we have
tower?
everything doubled up.
actually do this. And they slide into, I see.
So everything doubles up.
Alright, I'm just trying to satisfy rowing.
The
Yes,
bottom
there's
one,
plenty of
it's a little
space.
weird. We have a little bit of an angle in the tower. That's okay. We've got the start of a tower here. Might need it. Maybe it's like an arch.
But you can make it into a tower unit.
Yeah,
even
you can just stack them on top of each other.
Hey, oh, and look.
We could probably take some of the
Nice.
tensions out of these and
Yeah.
make them more what they are.
These are big towers. They go up and up and up and up and up. Mom and sister get going.
Loose part of it. And then
You can work on these things. We can learn more about this later. Mom insists on getting going so we can get dinner.
So your actual connection, if I
This particular one is missing something where it was like, this would help with the tension. And we gotta go. I'll take this one.
Be nice. A little asymmetry in the herd.
That's perfect. We're going to make a tower. Very cool.
So what do you notice as the front construction progresses? Where do you see it being too tight? Where do you see it being too loose?
I feel like the bands are too loose.
So the verticals are too loose. Is there anywhere you see it feeling too tight?
Just on the bottom.
So the pink ones might be kind of small, and you have extra length taken up with how you've wrapped it. So may I change it a little bit?
Yeah.
Okay, so I'm going to let out a little bit of the extra length. Okay. We'll let out a little bit of this extra length here. So you're on the right track of having that wrap
The two
secure.
things downstairs are all cool.
Good to be
We have
open to possibility.
Yeah, we might just head over to
split out so that we can go out on the land on it.
So wait,
And then if you sort the purple and the green similarly, I bet you will start progressing down.
I think all of mine are simultaneously too long and too short.
Ways
I'm not sure how to fix this.
Okay, so it looks like you used the really long ones for your triangle.
Yeah, so my really long
Yes. So
So,
absolutely easiest
Yeah.
way would be
So if it stands.
to pull the right ones out.
It does, strangely enough. It stands.
How do you couple them together?
So essentially the stacking portion of it is that
you've got it. So
corners go into the triangular bands
then it's going to come together
on
into the shape you're looking for.
and similarly so they wrap their ways in so that at the corners of the bottom piece work their way into the top bottom. The bottom's top works its way into the top spot, as it were. So you stick the skillers into the top, into the band, and you get the band of the bottom to work its way into the corners of the top, relatively speaking.
Okay. No, that makes sense.
And so in doing so, you generate all kinds of rather fun things that
You're
happen.
getting the hang of holding it too. Several hands at once.
Tape is on various places. There's some,
Yes.
some there, but there's some on the tape.
That's not quite it. One of them has managed to escape, but
Oh, yeah. Oh, the tape is vibrated.
Yeah, this is fine, but I was just like, do we have rubber bands short enough?
There we go. Pretty short. Although you will have to.
Oh wow. There we go.
Before that.
Gonna do it. Okay.
You can do this. Bob the Builder comes to mind.
I guess I don't know how to time out.
You can do this.
How do we do this?
I don't know, it's less than 4 dimensions. Like I did in grad school.
It's not boggling enough.
There you go, it's coming for you.
I lost more than a decade of my life studying topological geometry at the University of Illinois.
Oh dear. That is not time lost. That is lovely.
Which means you understand certain things and how to violate physics.
It was awesome. It was awesome.
Topological geometry, or how the universe says you think it first doesn't.
Supporting the string theory people?
There you go.
Lots of string theory.
I don't know what the official way is to join them.
So what I saw
You said that universe is
was that you have two, and so the sticks of the bottom go into each of the items
That's the physics
in
side.
the
That was
bands
the
top.
the math side.
math side.
And
Does always rise. You know it's
and then
So they kind of, they free float between.
and that what I also saw was that some of the top one of the bottom loops itself into each of the.
Yeah, my advisor spent a good deal of time trying to solve a point break
So
injector.
you get, thus you get
And then he
the
got
structure of both bands
Then he got really,
into,
really bad that
and so you essentially that's the idea is that you get them so that the structure of the top and the bottom become intertwined sort of at that point of joining. At the point of joining, and that sometimes you may need to occasionally adjust the tension.
That's it.
Yep, that's the easy way to stack them. And then you
What's
can
the
just
harder
keep
way?
stacking them.
Yeah.
There are
It's like,
different ways that you'll see people do it, where they'll do
somebody
the
needs to
cable
do
from
that.
like here to
Somebody needs to
here
finish
and
Oh,
stuff.
yeah.
you look at me.
They'll start to kind of add more
Yeah,
symmetries.
depending on where
So.
you want your kind of structural resilience
I
to,
see.
where you want to reinforce it, you can add them in different places.
Different habits
Yeah.
that are particularly strong.
This is just the like
Asymmetrical.
bare bones,
Yeah.
super duper simple. Now, there is a harder one that we can attempt if anyone wants to, but I feel like we're having fun with the free simplex.
It's the guy that goes in the ring that deserves the praise. He loses. He went in the ring.
So,
Tries to do the whole thing. I haven't done it.
this is cool.
Steal some
So did
photos.
you formally study?
Absolutely not. That's why I'm not teaching the math or anything.
Yeah.
Oh no. When you were measuring out where
You just like the
tape
hard,
it,
or the
how much
hard
attention do you want to put in the bands to decide where to put the tape line on?
So I like to think about
Later
keeping
graduate
like
students actually
a little bit of
managed to
attention.
take
I
some
feel
of
like
the stuff
yeah.
some of the notes that
Honestly,
I
I trial and error various materials because
done
if your
and
structure
do
is
something-
stronger,
do
they
something
can handle more
finish
tension
something
and
cool
you can
with
do more.
that
It'll be a
I
more
did-
stable,
never-
rigid final product. But then if your structs are mature, you might want a bit less
You
tension.
might want to not snap them.
All right.
And then when you put them together.
Okay.
So you see how these ends are basically little clips that can just grab onto another rubber band, right?
There we go.
Well, we're gonna grab these three ends onto the three stretches of band here. And then we're gonna grab those three ends onto the three stretches of band here. And then they're gonna become one and become part of.
So like middle of the
You may be happier if you use shorter rubber bands for your
That's on my schedule here for tomorrow. I mean, I'm happy to go.
The shorter rubber bands for.
I'll have to do have one.
It's funny to see the second person.
Okay. No, but I gotta get I want to lose track of who's not paired right now. Well, it's pretty good mark, but